Hello there, and welcome back to the Sleep Science. Tonight, you're not just lying in bed, you're hovering slowly above the world. The hum of your fan blurs into the distant rush of wind against a window, and your mind drifts upward. Curious, you imagine the air thinning, your lungs pulling in something that tastes a little less like oxygen and a little more like mystery. You probably won't survive this trip, by the way. Humans aren't exactly designed for open-air ascents beyond the breathable stuff. But it's fine, you're only imagining, so before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're listening from, and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You start by standing barefoot on soft grass. The night air feels dense, heavy with dew, carrying a faint tang of earth. Overhead, the stars shimmer faintly behind wisps of cloud. You tilt your head and think, where does that stop being sky? It's a childish question, but the best ones often are. Your body rises, not fast, not like a rocket, just a slow, steady drift upward. The sound of crickets fades, replaced by the whisper of air molecules colliding against your cheeks. You are with every meter climbed. The blue begins to darken, the stars sharpen, and the warmth from the ground slips away. At about 10 kilometers up, cruising altitude for a passenger jet, you pass through the top of the troposphere. Down below, the weather still brews storms and rain, lightning and turbulence. Up here, it's oddly calm, like slipping above the drama of daily life. The cabin of a jet normally shields you from this strange stillness, but tonight there's no fuselage, no seatbelt sign. The only thing separating you from the edge of everything is thinning air and a rapidly shrinking sense of home. You reach the stratosphere around 20 kilometers up, where the sky has turned a deep indigo. Your breath would be gone by now, oxygen too thin, pressure too low, but you're not here to breathe, just to observe. The ozone layer hums quietly around you, invisible but crucial, filtering ultraviolet light like a pair of cosmic sunglasses. The French scientist Léon Tisserand de Boer discovered this region in 1902 using hydrogen balloons and thermometers sealed in glass. He found that oddly, temperature stopped dropping with height here. It leveled off, then warmed again. Historians still argue whether he truly grasped the ozone's role or if it was pure luck. Either way, the man knew how to ruin a balloon ride. Higher still, you drift into the mesosphere. The temperature plunges again, below minus 90 degrees Celsius. Here is where meteors meet their fiery fates, tiny rocks colliding with molecules so rare that even one touch can vaporize them in a burst of light. You remember watching a shooting star once, making a wish. It's funny to think that what you wished on was technically space trash dying in the upper atmosphere. Somewhere a meteor burns right beneath your feet now, and you realize space doesn't start with a line. It starts with a fade. By the time you pass 80 kilometers, the air is nearly gone. You can't hear your own heartbeat, not because it's silent, but because there's nothing left to carry the sound. The horizon curves sharply beneath you, a massive marble wrapped in cloud. That blue edge, the one that astronauts photograph so often, isn't an edge at all. It's atmosphere seen sideways, sunlight scattering through a fragile, glowing film. The colour makes you nostalgic, the way blue always does. It's the colour of sky and sea, and every moment you ever looked up and thought there must be more. The word space feels wrong now. It suggests emptiness, but this place is full of radiation, of whispers of old satellites, of possibilities. Somewhere nearby, the International Space Station glides in silence, orbiting at roughly 400 kilometers. Inside, astronauts float between experiments and microwaved meals, calling down to Earth as if they hadn't just stepped outside humanity's cradle. They cross the edge 16 times a day because orbital motion makes the concept laughably relative. You pause in the quiet void, trying to sense where Earth's authority ends. Gravity still tugs at you, though gently. It doesn't stop here, nor at the moon, nor even where sunlight thins into darkness. The truth is, there's no wall. The planet doesn't have a frontier, it just loses its grip atom by atom, dream by dream. Back below, at sea level, school children still draw a tidy line labelled, "Space begins here." Teachers call it the Kármán Line, 100 kilometers above Earth, but even that is more politics than physics. Some nations claim the boundary lies at 80 kilometers, others stick to 100. Astronaut wings have been awarded and denied based on this invisible argument. One day, the definition might shift again, not because the sky changed, but because humans can't resist drawing borders on the infinite. A faint speck catches your eye, a satellite tumbling in slow motion, its panels reflecting sunlight from far below the horizon. Space junk, maybe. Thousands of fragments circle Earth, each one a forgotten fragment of ambition. A lost wrench, a paint chip, a piece of a 1960s rocket stage, all racing faster than bullets. Historians still argue whether we've already trapped ourselves in a debris field that could one day make leaving the planet impossible. You can't help smirking at the irony. Humans tried to reach the stars and ended up littering the front porch. Your ascent slows as you look down once more. From here, continents blur into watercolour shapes. The thin, glowing band of air that separates us from out there suddenly seems heartbreakingly small, about as thick as an apple's skin if Earth were the fruit. That's all we have between breath and vacuum. It makes every inhale you've ever taken feel like a small miracle, one you didn't know you were spending. A cold calm spreads through you. Above, the stars no longer twinkle. They blaze steady and sharp, free from atmospheric wobble. The moonlight paints your hands silver. You realise that if there is a border between Earth and space, it's not in altitude, it's in perception. It's the instant you stop thinking of up as direction and start thinking of it as freedom. The thought makes you laugh quietly. A stray breath fogs and disappears into the void. You have stepped, imaginarily and softly, into a realm without edges. From here on, every meter you rise will be called space, but the transition happened long ago, somewhere between curiosity and awe. You linger, suspended, feeling the planet's slow rotation beneath you. Oceans swirl. Lightning forks across unseen clouds. From this height, humanity looks peaceful, like a sleeping child. You can't tell where borders lie or where wars are waged. There's only blue, then black, then the subtle shimmer of hope that maybe someday we'll stop asking where space starts and start asking how far imagination can take us. You hover there, suspended between blue and black, and realize you've hit a kind of bureaucratic problem. Space may be vast, but humans still found a way to argue about where it officially begins. Beneath you, the Earth spins silently, full of scientists, pilots and lawyers, all tugging at the same invisible thread. The Kármán Line, the imaginary boundary where air supposedly gives up and space begins. It sounds clean, scientific, definitive, but of course it isn't. Nothing in science ever really is. You drift higher toward that symbolic altitude of 100 kilometers above sea level, the so-called edge of the world, and can't help but wonder why everyone is so desperate to pin it down. You reach it, the big one, a number that exists more in international treaties than in physics textbooks. You'd expect some kind of marker, maybe a glowing ring of light or a sign reading, "Welcome to space, please keep your arms inside the planet." But no, it's just more sky, thinner and darker. The view doesn't suddenly switch, the wind doesn't pause, you don't hear a cosmic chime. It's like stepping across an imaginary border in a desert. No fence, just the human urge to draw one. The Kármán Line is named for Theodor von Kármán, a Hungarian-American aerospace pioneer who spent the 50s trying to define where aeronautics ends and astronautics begins. He calculated that around 100 kilometers up, the atmosphere becomes too thin for a traditional airplane to generate lift, meaning that beyond this point, flight as we know it gives up and orbital mechanics take over. It's the sky's last breath. It's tidy, rational, mathematical, and wildly arguable. The US Air Force, for instance, prefers to set the bar lower, around 80 kilometers, because, well, their test pilots were already hitting that height and wanted the astronaut wings. Historians still argue whether the decision was more about science or pride. Hint, probably both. As you float in this undefined zone, you realize that space is as much a social construct as a physical one. The Fédération Aéronautique Internationale, try saying that name 3 times slowly, uses von Kármán's 100-kilometer mark for record keeping. The United States sticks stubbornly with the 80 kilometers. The European Space Agency depends on the paperwork, and private space tourism companies? They just pick whichever line lets them market their customers as astronauts. If someone paid $250,000 for the ticket, you can bet the brochure calls it space. Down below, pilots and scientists once risked their lives chasing these invisible altitudes. In 1963, Joe Walker, a NASA test pilot, flew the X-15 rocket plane to 107.8 kilometers, just nudging past the Kármán Line. 2 years later, the same craft reached 108 kilometers again. Walker got his astronaut wings, of course, though only after years of debate. Apparently, bureaucracy travels faster than sound. Decades later, a company called Blue Origin made headlines for sending civilians to about 106 kilometers, barely over the threshold, while rival Virgin Galactic hovered around 85. Cue the internet comments section declaring who really went to space. Humanity can split atoms, but not definitions. You reach out a hand as if you could feel the shift. The air is still too thin to carry sound. Your movements create no echo, yet something feels ceremonial about crossing this point. Beneath you, the atmosphere curves away, glimmering faintly in sunrise gold. Above you, true blackness, starfields sharp enough to cut your gaze. For all the arguments and footnotes on me, the human brain insists that this must be the edge. It feels different here, not because physics says so, but because the heart does. A faint flicker catches your eye, a piece of old rocket debris tumbling lazily past, a reminder that our space frontier is already sprinkled with leftovers. There's a bolt from a 1960s launch, a fleck of paint from a long-dead satellite, maybe even a frozen droplet of coolant glinting like a fake star. Space may begin wherever we say it does, but the mess starts right here. Below, you can almost hear Earth's history arguing about edges. In the ancient world, philosophers thought of the heavens as layered crystal spheres, the firmament holding the stars like jewels. Then Copernicus and Galileo cracked that idea open, revealing the sky as motion and mathematics. But even they had no real sense of where up stopped. They just knew it was farther than anyone could climb. Now, centuries later, humanity's greatest minds are still drawing invisible lines in invisible air. Historians still argue whether von Kármán himself would laugh at what became of his thought experiment. A diplomatic measuring stick, not a scientific truth. A gustless silence stretches around you. If you could look sideways at the planet's limb, you'd see the Kármán Line shimmering only in imagination. The sun edges into view, flooding the horizon with colour that fades instantly into blackness. It's breathtaking and strangely bureaucratic all at once, the most beautiful argument ever made. You remember that in 21, two men with very large wallets, Jeff Bezos and Richard Branson, launched separate suborbital joyrides, each claiming to have taken civilians to space. Branson's flight peaked at about 86 kilometers, Bezos is at 107. Cue the headlines: who went higher? The truth. Both reached the thermosphere, neither reached orbit. Both returned with giant grins and very slightly singed egos. The debate still smoulders online, as though altitude alone measures adventure. A quirky side note drifts into your mind. In 2018, a group of engineers proposed redefining the edge of space dynamically, where the speed needed to stay aloft equals orbital velocity for that altitude. The catch? That line shifts constantly with solar activity and atmospheric density. In other words, the edge of space moves. The universe doesn't care about our paperwork. It breathes, flexes, and ignores us entirely. You glance downward again, the planet's blue fades into pale silver. Cloud tops catching the light. The thinness of that luminous line below makes your chest tighten. A reminder that life is both fragile and stubborn. If the air vanished, so would we. Yet here you are, riding imagination past the threshold, discovering that borders dissolve when you stop needing them. Your body continues upward, but your sense of place doesn't. The Kármán Line may exist on maps and in treaties, but in this quiet vacuum, it feels absurd. The stars don't care who gets the title astronaut. The air doesn't consult your passport. Somewhere a cosmic ray from a dying star billions of years ago brushes past your cheek. That's the only real boundary, between the particles that still belong to Earth and those that come from everything else. You take one last look down at the invisible divide, then smile softly. The Kármán Line, science's neat little fiction, has done its job. It gave humanity a symbolic ceiling, a way to say, we've left home, but tonight, you know better. There was never a wall to cross, only a story to tell. The air is gone now, at least in any familiar sense, and as you drift higher, you pass through the last fragile breaths of what can still be called atmosphere. The planet below glows like a breathing jewel, wrapped in invisible shells, each one a little thinner, a little colder, a little lonelier. You start to realize that the Earth doesn't end abruptly. It fades away through layers, each a different mood of the sky. You feel them like soft veils brushing past, ancient and alive, whispering their names: troposphere, stratosphere, mesosphere, thermosphere, exosphere, a staircase of breath leading into silence. You think of the troposphere first, the bottom layer, the one you were born into. It's where clouds live and where every weather forecast on Earth makes sense. It's about 12 kilometers thick on average, thicker at the equator, thinner near the poles, because heat stretches the air like taffy. This is the layer of thunder, rainbows, and the occasional misplaced plastic bag doing its lazy dance. Here, airplanes hum and birds glide. You can still smell life in it: ozone after a storm, the dust before rain. Without the troposphere, we wouldn't have sunsets, just a bleak, sharp light cutting through vacuum. Historians still argue whether the first person to truly understand its upper limits was Léon Tisserand de Bourg again, or an earlier balloonist who simply got too cold to take notes. Either way, the human habit of curiosity continues to outclimb common sense. You rise higher and enter the stratosphere, about 50 kilometers up. The air here barely stirs. No storms, no turbulence, just slow drifting currents. It's peaceful, the kind of silence you could fall asleep inside. This is where weather balloons burst, and where ozone performs its quiet miracle of filtering ultraviolet radiation. You glance toward the horizon and see that peculiar blue glow, the one that always shows up in astronaut photos. That's Rayleigh scattering, fading away, the dance between sunlight and air molecules that makes our sky blue in the first place. In this stillness, you think of the Concorde, that supersonic white dart that once sliced through this layer at twice the speed of sound. The cabin windows showed a darker sky than any other passenger plane ever could. The world mourned when it was retired, as though humanity had lost one of its feathers. A little joke drifts through your sleepy mind. If you ever need to escape small talk about the weather, just go above the weather entirely. Up here, there's nothing left to complain about, not even humidity. You're beyond forecasts, beyond umbrellas, beyond the reach of rain. Now you enter the mesosphere, a realm so high that no plane can fly and so low that satellites can't orbit. It's the Earth's no man's land, where temperature drops again to minus 90 degrees Celsius and shooting stars streak in glorious suicide. Every meteor you've ever seen ends its story here, vaporizing into nothing more than light and wishful thinking. You can almost taste the cold, metallic tang of the upper air. A faint green shimmer flickers along your vision. It's the faint trace of noctilucent clouds, made of ice crystals dancing on the edge of nothingness. The first confirmed observation of these clouds was in 1885, just after the eruption of Krakatoa filled the atmosphere with volcanic dust. Scientists still debate whether those glowing wisps were born from the eruption or simply revealed by it. The sky, like all good magicians, never reveals its tricks easily. As you drift upward, the faint blue of Earth's halo turns deeper, darker. You pass quietly into the thermosphere, starting around 90 kilometers and stretching up hundreds more. It's here that auroras bloom, vast curtains of neon green and violet caused by solar particles colliding with atmospheric gases. The show feels almost spiritual, like the planet breathing light instead of air. You could reach out, you think, and touch the shimmer, but it would pass through your hand like a ghost. Temperature here can soar to 2500 degrees, though. If you were somehow present in body, you wouldn't feel it. There aren't enough molecules to transfer heat. It's like being surrounded by a furnace that forgot how to burn. You remember reading once that during the Cold War, scientists accidentally created an artificial aurora by detonating a nuclear device high in the thermosphere. They were testing the behavior of charged particles, or at least that's what the paperwork said. The light display was visible across oceans. Historians still argue whether the experiment was pure research or just a flex of technological bravado. Either way, it left a faint eerie echo, a man-made ghost haunting the sky. Above the thermosphere lies the exosphere, the final wispy veil of Earth's presence. You pass through it like fog made of memory. There's no clear border here, just atoms drifting farther apart until they slip into orbit or wander off into interplanetary space. Hydrogen, helium, the occasional trace of oxygen, these are the last breaths of the planet exhaled into the cosmos. It stretches thousands of kilometers outward. invisible but continuous. You could be inside it right now and never know. In fact, the moon moves through its outermost edge like a silent visitor passing through an invisible mist. The idea makes you smile. Even the moon is still technically within Earth's atmosphere, just barely clinging to the ghost of home. You pause in the silence, feeling layers below you like pages of a story you've already read. Each one taught humanity something new, each one peeled back by balloonists, pilots, and satellites. You imagine Auguste Piccard, the Swiss physicist who ascended to 16 kilometers in a pressurized gondola in 31, measuring cosmic rays and nearly freezing to death. He became the first human to see the curvature of Earth with his own eyes. When reporters asked him what he saw up there, he simply said, "The sky turned black." That's it. No poetry, just observation. You suspect he was too cold for poetry. The funny thing is, all these layers are constantly moving, expanding and shrinking depending on the sun's temper. Solar storms can swell the thermosphere so much that satellites dragged lower and burn up early. Historians still argue whether early engineers underestimated solar variability or just gambled on optimism. It's a comforting thought. Even geniuses miscalculate when staring into the unknown. You hover now just beyond the exosphere, surrounded by faint traces of what was once air. Below, the layers blur into a single shimmering ribbon, wrapping the planet in colour and light. You realise that this, more than any line or law, is where space truly begins. Not because physics says so, but because your senses finally run out of material to hold on to. There's no more wind to feel, no more sound to hear, no more scent to name. Just silence, infinite and intimate. For a moment, you think of Earth's atmosphere as something fragile, like glass. Then you realise it's more like skin, alive, breathing, protective. Without it, the planet would be just another cold rock. With it, everything becomes possible. Laughter, rain, songs carried on wind. You drift upward still, watching the layers fade, each one whispering its goodbye. The colour begins to fade. That vivid electric blue that once filled your childhood drawings of the sky is dissolving into ink. You hover, motionless, watching the hue melt from turquoise to midnight, from atmosphere to void. It's strange how something as ordinary as colour can unravel into nothing at all. The sunlight still pours in from one side, yet the stars are visible now, crisp and unmoving. This is the part where the blue disappears, the vanishing point of the sky. You've left the atmosphere behind, but what's really leaving you is the illusion that there's anything solid between you and infinity. You look down at the horizon, and the earth glows like a polished marble, rimmed with that razor-thin arc of azure. From above, it looks less like a world and more like a thought, a perfect gradient from gold to cobalt to black. The air, that invisible ocean you've lived in all your life, reveals its boundary through colour alone. You realise that blue was never really the sky's colour. It was sunlight scattered by nitrogen and oxygen, a kind of optical prank. Lord Rayleigh, the 19th century British physicist, figured that out by studying why the sunset glows red. He discovered that shorter wavelengths, blue light, scatter more easily, filling the sky during the day. Historians still argue whether he intended to solve a grand mystery of nature or was just trying to explain why his laboratory looked perpetually dusty. Either way, the result changed how humanity saw the heavens, not as a dome, but as a dynamic trick of light. As you float higher, you watch the sunlight stretch and thin, like honey poured into cold water. Shadows sharpen. The blue gives up. The darkness above you isn't darkness at all. It's the absence of scatter, pure unfiltered space. It's the real colour of the universe. You tilt your head, and the stars don't twinkle here. They burn steady and cold, as if relieved to finally be seen properly. The twinkling, you realise, was just Earth's atmosphere jittering the light, tiny pockets of hot and cold air bending starlight like rippling glass. A simple optical illusion, hiding the perfections of space. You can't help but think of the astronauts who first saw this in person. In 1, Yuri Gagarin looked down from orbit and said, "The sky is very dark, the Earth is bluish." The understatement of the century. He didn't say it poetically, he said it like an engineer, which somehow makes it even more poetic. There's something humbling about knowing that the first human in space described the entire cosmos like he was filing a weather report. Historians still argue whether that quote was scripted for propaganda, or genuinely his own words. But it doesn't matter. The emotion beneath it is undeniable, an awe too big for sentences. You feel it too, that quiet awe. The planet is impossibly fragile, the light bending around its edges like a halo. You imagine the sun setting behind the curvature, the golden line shrinking until only a blood-red glow remains. From up here, sunsets are faster, sharper, more final. On the International Space Station, astronauts see 16 of them every single day. The planet spinning below like a restless marble. They say that each one still makes them stop what they're doing. Even after hundreds of orbits, the vanishing blue still feels holy. A random thought crosses your sleepy mind. If colour depends on air, does that mean space is colourless? Or are we simply blind to what colour becomes when light stops scattering? It's like asking what sound silence makes. Maybe the answer isn't absence, but transformation. In ancient Egypt, priests believed that the sky was the goddess Nut, her body arched across the world, dark and jewelled with stars. To them, the black of the heavens wasn't emptiness, it was divinity. You can almost imagine that now, the way the darkness curves over you like a living thing. You glance toward the limb of Earth again. That sharp line between light and night known as the Terminator. It's a word that sounds aggressive but simply means boundary. From here you can see night creeping across continents, swallowing cities like a tide of shadow. On the day side, sunlight gleams off oceans and ice caps. On the night side, a web of city lights glitters like spilled circuitry. The transition is breathtaking, like watching a planet breathe between wakefulness and dream. And still, the blue keeps fading. Somewhere beneath you, commercial pilots soar at 10 kilometers, seeing a faint navy tint. Weather balloons rise to 30 kilometers, watching the color turn violet. And above 60, it's already mostly black. The transition doesn't happen at one height, it happens across the senses. You realize that the vanishing blue isn't a moment, it's a process. Slow and melancholic. Like the fading of a song you didn't want to end. You stretch your fingers toward the curve of Earth, though of course it's untouchable. The sunlight on your skin feels thin, filtered, sharp. If you could measure it, you'd find that ultraviolet light is stronger here, unsoftened by ozone. Your shadow falls perfectly crisp against nothing. It's oddly beautiful, and just a little sinister. Space doesn't glow, it glares. You remember hearing that some astronauts describe a distinct smell when they return from spacewalks, a burnt metallic scent clinging to their suits. The leading theory, atomic oxygen, abundant at the edge of the atmosphere, reacts with metal and carbon during re-entry, leaving behind a trace odour like welding fumes and gunpowder. It's one of those weird sensory echoes that brings the idea of space back down to human scale. Historians still argue whether the smell is real chemistry or just suggestion, but every astronaut swears it's there. The fading of colour feels like the closing of eyes. You blink, and the world below glows softly in blues and whites, like a nightlight left on for safety. For a moment, you think of how much of human emotion depends on colour. The red of warning, the green of comfort, the blue of calm. Strip that away, and you're left with pure light and shadow, truth without filter. Space doesn't lie. It shows everything as it is. You let yourself drift, basking in the glow of half-light, the quiet hum of solar radiation filling the void. The vanishing blue becomes complete black now, the true threshold crossed not by distance, but by perception. You're seeing what the universe looks like when the sky steps aside. It's beautiful but humbling. The darkness doesn't feel empty anymore, it feels honest. The stars blink silently, patient and ancient, and the earth gleams below, luminous and delicate. You realize you've never really seen blue until you watched it vanish. You've been rising for what feels like forever, yet something keeps tugging at you. A gentle, invisible pull that refuses to let go. It's not nostalgia, not homesickness, it's gravity. You thought that once you escaped Earth's atmosphere you'd be free, weightless, floating in clean mathematical emptiness. But here you are, still tethered. Gravity, it turns out, doesn't stop at the edge of space, it stretches endlessly, a cosmic leash made of patience and persuasion. You start to understand why astronauts never really escape Earth. They just fall around it forever. The sensation is subtle. You can't feel the pull directly, but you see its evidence everywhere. The moon, for instance, dances obediently in its orbit, caught in Earth's field. Its gravity shapes tides, guiding oceans twice daily like a slow breath. The International Space Station, only a few hundred kilometers above, isn't beyond gravity, it's deep within it. The crew up there feels weightless, not because gravity is gone, but because they're falling with it, perpetually missing the ground. Isaac Newton described it centuries ago. If you throw a cannonball fast enough, it curves around the world instead of crashing back down. Historians still argue whether Newton ever imagined people would actually live inside that thought experiment. Probably not, but he'd be smug if he knew how right he was. You tilt your head downward. Earth dominates the view. Massive, alive, magnetic. You realise that this invisible force isn't just keeping you attached to the planet, it's keeping the entire solar system organised. The sun's gravity holds Earth, Earth holds the moon, Jupiter holds its dozens of moons, everything holds something else. Space isn't a void, it's a web of attraction, a slow-motion dance choreographed by invisible hands. You can almost hear the rhythm of it, if silence had sound. It's humbling to realise that you are never truly free of gravity, not even in deep space. The farther you go, the weaker it gets, sure, but it never completely disappears. Even a rogue comet drifting between stars still feels the faint whisper of every mass it passes. Gravity is the universe's gossip line. It spreads information everywhere, quietly shaping destinies. The funny thing is, gravity is the weakest of the four fundamental forces. Pathetically weak, really. You can pick up a paperclip with a fridge magnet, and for that moment, your tiny magnet defeats an entire planet's gravitational pull. And yet, gravity dominates the cosmos because it never lets go, no matter how far it reaches. The others, electromagnetism, strong, weak, they fade in short range. Gravity is the long-game force, the one that plays eternity like a strategy board. As you drift farther, you start to see how space behaves under its spell. Every orbit is a compromise, a balance between falling inward and flying outward. The moon does it. So do satellites. Even your own ascent right now depends on it. The higher you rise, the slower you need to go to stay tethered. Go too fast and you escape Earth's grasp, too slow and you fall back. There's no resting in orbit, only perpetual motion. You picture the Apollo missions, those daring leaps of math and metal. To reach the moon, NASA had to calculate the perfect point where Earth's gravity gives way just enough for lunar gravity to take over. That halfway spot, the saddle of forces, is called the Hill sphere. Beyond it, Earth's claim starts to fade. But even there, it never vanishes entirely. Some particles, some atoms, will always stay Earth's loyal subjects. Historians still argue whether early mission planners fully understood these delicate transitions, or were just building elegant guesses that happened to work, knowing engineers, probably a bit of both. A small smile crosses your face as you remember those old sci-fi movies that imagined astronauts floating serenely in space, totally detached. The reality is so much more poetic. Everyone and everything is always falling. Even galaxies fall toward each other across millions of light years, drawn by mutual gravity like shy lovers pretending it's coincidence. The Andromeda Galaxy, our nearest major neighbour, is already on a slow-motion collision course with the Milky Way. In about 4 billion years, the two will merge into one enormous glittering storm of stars. The future universe will shimmer with the proof that nothing ever really lets go. You stretch your hands and look at your fingers silhouetted against the curved horizon. If you could measure your own gravitational pull, it would be microscopic, yet technically so. Every atom in your body is tugging faintly on every atom of Earth, and vice versa. You and the planet are in a tiny, constant relationship of attraction. It's almost romantic in a weird physics way. You smile at the thought, gravity is the ultimate long-distance relationship, but there's more to this than poetry. You start to think about Einstein, who reimagined gravity not as a pull, but as the curvature of space-time itself. According to him, mass tells space how to curve, and space tells mass how to move. You can almost feel that now, the way Earth's presence warps everything around it. You're not so much held by gravity as sliding through a bent geometry. In a sense, you're already falling straight. Space itself just happens to be curved. It's the most elegant explanation in all of science. And yet it sounds like something you'd whisper to calm yourself before sleep. Still, the details are debated even now. Historians and physicists alike argue about whether Einstein's equations fully capture the strange behavior of dark matter and dark energy, forces that seem to warp the cosmos in ways gravity alone can't explain. Maybe space isn't just curved. Maybe it's alive in some way, shifting and breathing beyond what we can see, for now you accept the mystery, is oddly soothing, knowing the universe still keeps some secrets close. You look back at Earth again, massive, radiant, slow turning. You realise that you're still within its gravitational love song, still part of the endless cascade of falling and spinning. Every orbiting body, from satellites to moons to dust motes, participates in this same cosmic ballet. You thought space began where Earth ended, but now you understand Earth doesn't end at all. Its reach stretches endlessly outward, invisible but absolute. You close your eyes and feel that faint, eternal tug, a whisper of weight that reminds you where home is, no matter how far you drift. It's not confinement, it's connection. The Earth's hand holding you gently by the heart, saying without words, you never really left. The air has long vanished, the blue has bled away, and yet you find yourself surrounded by something you can't see. A vast protective cocoon, wrapping Earth like an invisible guardian. You've entered the magnetosphere, that shimmering magnetic shield that deflects deadly solar winds and cosmic radiation, the invisible armor that keeps Earth habitable. You can't touch it, can't smell it, can't see it directly, but you can feel its presence in the way particles around you begin to dance, charged, erratic, alive. It's as though the planet itself is whispering, "Not today, son." You glance downward. Earth's magnetic field flows out from the planet's molten core, arcs into space and snaps back in long looping tails behind the night side. It's not a perfect sphere, but a distorted teardrop constantly sculpted by the solar wind. The field lines look like glowing ribbons in your imagination, twisting gracefully, shielding everything living below. If you could see it with your eyes, it would resemble a giant bubble flickering in solar light, fragile in appearance, yet strong enough to deflect most of the sun's fury. Historians still argue whether early scientists like William Gilbert, who compared Earth to a giant magnet in 1600, truly understood the cosmic scale of what they were describing. Probably not, but their guesses were uncannily close. The magnetosphere begins around 1,000 kilometers up, far beyond where air ends, and stretches outward for tens of thousands more. On the day side, it compresses tight under the sun's pressure. On the night side, it stretches into a long tail that trails like a comet's. You're floating now in that frontier, where charged particles zip by like fireflies on caffeine, guided by magnetic lines that you can only imagine. Some of these particles are from the sun, hurled out during solar flares at nearly 1,000,000 kilometers per hour. Others are relics of ancient cosmic events, still wandering after billions of years. The magnetosphere catches them all, sorts them, traps some in invisible belts around the planet. Those belts, the Van Allen radiation belts, are regions of charged particles held captive by Earth's magnetic field. They were like invisible prisons, constantly shifting, swelling, and sometimes leaking. You hover near the edge of the inner belt, and the silence feels tense, electric. In 958, when the Explorer 1 satellite first detected them, scientists were stunned. Until then, they'd imagined space near Earth as relatively clean. Suddenly, they realized the planet was encased in radiation. The discovery reshaped how humans designed spacecraft, how we understood solar storms, even how we defined safe. Historians still argue whether James Van Allen himself was proud or slightly terrified by his namesake belts. He probably smiled nervously and kept calculating. You picture what happens when the sun erupts, massive coronal ejections blasting billions of tons of plasma into space. If one of those waves hits Earth, the magnetosphere flexes, bends, and sometimes cracks open briefly, funneling particles down toward the poles. The result? Auroras, the northern and southern lights, curtains of green and pink energy flowing through the sky. Like the planet is painting with plasma. They're not just pretty lights, they are the visual language of survival, the magnetosphere translating cosmic violence into beauty. You remember how in 1859, a particularly massive solar storm, the Carrington event, made auroras visible as far south as Cuba and set telegraph lines on fire. Historians still argue whether a storm of that scale could happen again, and whether our modern electrical world could survive it. Spoiler, probably not. You let your gaze drift upward, into the darkness where solar particles are still being deflected. You can almost hear them hiss, an electric chorus beyond human hearing. It's funny, you've always imagined space as empty, but this place is anything but. It's buzzing, chaotic, alive with invisible movement. The magnetosphere is less like a bubble and more like a living organ, flexing and pulsing with every solar heartbeat. You think of all the tiny things it protects: oceans, forests, people asleep under blankets, satellites orbiting quietly. Without this magnetic shield, the solar wind would strip away our atmosphere molecule by molecule. That's what likely happened to Mars. The red planet once had its own magnetic field, powered by a molten core like Earth's, but it cooled billions of years ago. Without that shield, the solar wind swept Mars clean, leaving only traces of an ancient ocean and a ghost of an atmosphere. The difference between blue Earth and red Mars might come down to a magnetic heartbeat that never stopped. A whimsical thought flickers through your tired mind. If the magnetosphere is Earth's invisible armor, then the auroras are its mood ring. When the sun gets angry, the colors flare. When it's calm, the sky stays quiet. You like that idea, the planet having moods, visible only from space. It makes Earth feel less like a rock and more like a living creature. Below you, the poles gleam faintly, green lights spilling and curling like the world is sighing in color. You remember that astronauts often describe auroras from above as rivers of light, moving so quickly they look alive. Some even say they can hear faint static sounds when passing through areas of high particle activity. There's debate over whether that's imagination or instrumentation. Historians and scientists still argue whether auroras truly tänker, but you kind of hope they do. It would be rude for something so beautiful to be obedient. Your thoughts wander briefly to the satellites orbiting nearby, each one relying on the magnetosphere's protection to survive. GPS networks, weather trackers, even the ISS. All of them exist in this fragile equilibrium between cosmic chaos and Earth's magnetic mercy. When solar storms swell, engineers scramble to shut systems down, shielding circuits from surges. It's like nature's reminder that no matter how advanced we become, we're still guests in a powerful magnetic field. A slow comfort spreads through you. The magnetosphere isn't visible, yet its presence feels intimate. An unseen guardian watching over every breath, every sunrise, every small human endeavor below. You start to see space differently now, not as a hostile void, but as a stage where forces unseen constantly negotiate our survival. The sun flickers on the horizon, a raw white glare that makes your eyes ache even in imagination. The planet glows beneath, wrapped in invisible threads of magnetism. You realize that this boundary, the edge of Earth's magnetic reach, isn't just a line of protection. It's a handshake between worlds, where energy from the sun meets resistance from the planet and finds harmony instead of destruction. You drift there for a long time, watching light and shadow twist around the curve of the globe. Somewhere in the silence, you think you can almost hear the hum of the magnetosphere, a soundless lullaby keeping you safe in a storm that never ends. You coast along the boundary of that magnetic shield, where the safety of Earth begins to blur into something more chaotic, a kind of cosmic frontier that's already cluttered with the artifacts of human ambition. Here in low Earth orbit, space isn't empty at all. It's crowded. If you could freeze time for a moment and illuminate every object circling the planet, the view would be dizzying. Tens of thousands of satellites, rocket stages, nuts, bolts, and flakes of paint, all whirling in tight overlapping loops at speeds faster than bullets. You expected solitude up here, but instead you've stumbled into a traffic jam. You drift slowly between the invisible lanes of this celestial highway. The oldest pieces move sluggishly in decaying orbits. The newer ones zip by, sleek and purposeful, broadcasting data and television, weather maps and TikToks. Each glint of metal is a story, the echo of a launch, a mission, or a forgotten experiment. The funny part? Even the dead ones don't leave. Space doesn't have a trash service. Everything that's ever been launched but not deorbited still circles somewhere above your head. It's like humanity built a museum of obsolete dreams and forgot to close the gift shop. A small object spins past, a smooth silver sphere, battered by decades of radiation. You recognize it immediately. Sputnik 1, or rather, what remains of it. When the Soviets launched it in 1957, it orbited for only 3 months before burning up, but the echo of that beep 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 still haunts the airless sky. That sound changed everything. It was the starting gun for the space race. Historians still argue whether Sputnik was more of a scientific triumph or a political statement. Either way, it made Earth look upward with both awe and envy, and you pass the wreckage of later years. bits of spent rocket boosters, solar panel fragments, a torn satellite antenna twisting slowly in sunlight. They look harmless, almost peaceful, but each piece moves at nearly 8 kilometers per second. Even a screw at that speed could tear a hole through steel. In 2009, 2 satellites, a dead Russian military one, and an active US communications satellite, collided at this altitude, scattering thousands of new fragments. The event triggered what scientists now call the Kessler syndrome, a nightmare scenario where debris creates more debris until orbit becomes unusable. Historians still argue whether we've already passed the tipping point. Some say we're one bad collision away from turning Earth's orbit into a glittering lethal halo. You glance toward the horizon and see the thin band of atmosphere glowing below, tinted by the sunrise. It's beautiful, serene, and entirely deceptive. Just beyond that line, chaos reigns. There's a hum of energy here, the invisible electricity of all those satellites communicating across frequencies, a digital heartbeat encircling the world. You can almost hear it, a soft static murmur of human presence in a place where humans don't belong. You drift past something larger now, a sleek metal shape catching the sunlight. It's the International Space Station, orbiting at about 400 kilometers. It looks fragile, more like scaffolding than a home, but inside people float, sleep, and laugh. They pass you every 90 minutes, circling the globe 16 times a day. Each sunrise for them lasts only a few seconds before becoming night again. They live between day and darkness, forever chasing dawn. You imagine one of them pressing a nose to the window, gazing out, unaware that you're drifting invisibly nearby. The ISS is both a symbol of unity and a reminder of fragility. Built by 16 nations, it represents what happens when politics yield, however briefly, to wonder. But it's aging now. Its metal bones creaking from decades of radiation and micro-impacts. Plans for replacement to stations float in bureaucratic limbo. Historians still argue whether it will be remembered as humanity's first home in space or as an expensive temporary outpost in a long line of forgotten prototypes. You think of all the other satellites circling here, serving every possible purpose. Some track hurricanes, others monitor crops, others spy. Some beam internet to remote villages, others stream reality shows to living rooms. Together they form an invisible infrastructure, space as the nervous system of Earth. Yet for every functioning satellite, there's another that's broken, derelict, tumbling without control. It's like a city built in orbit, half of it abandoned. Your body drifts past an empty rocket shell, its paint blistered and scarred by micrometeor impacts. You reach out as it spins, reading faint Cyrillic letters faded by sunlight. This, you think, is the cost of reaching upward. We leave fingerprints even on the void. A small chuckle escapes you. Trust humans to bring litter wherever they go. You imagine some future archaeologist, centuries from now, orbiting in a sleek ship, cataloguing debris and saying, "Ah yes, the plastic age. They even threw away their satellites." Beyond the jokes, there's an eerie truth. Low Earth orbit is starting to resemble a scrapyard. Engineers constantly track thousands of objects the size of golf balls, but millions more are too small to see yet deadly enough to destroy spacecraft. Each fleckus of paint is a bullet waiting for bad luck. The US Space Surveillance Network logs their paths meticulously, issuing collision alerts that astronauts sometimes have to act on within minutes. Spacewalks can be postponed or cancelled entirely if debris clouds drift too close. Humanity's greatest adventure has become a delicate balancing act between progress and self-inflicted peril. A curious thing about this altitude, you can still faintly feel Earth's drag. There's just enough residual atmosphere to slow satellites down over time, pulling them lower until they burn up in streaks of light. Every shooting star you've ever wished on might once have been a fragment of human technology returning home in fire. You think that's oddly poetic, ashes to atmosphere, pixels to plasma. A quirky tidbit crosses your mind. In 1963, NASA released hundreds of millions of tiny copper needles into orbit to test radio reflection. The experiment was called Project West Ford, a space ring of metallic hair meant to create an artificial communication network. It mostly failed, though a few clusters remain in orbit to this day. Historians still argue whether it was a bold experiment or the world's first instance of orbital littering. Either way, it's a reminder that human creativity often borders on chaos. You look back toward Earth, its blues and whites glowing against the infinite dark, and feel a pang of tenderness. Despite the clutter surrounding it, it's still breathtaking. A fragile sphere wrapped in technology, mistakes and dreams. Every piece of junk up here began as hope, and somehow that makes the mess forgivable. The planet rotates slowly below, unbothered by the swarm around it. You realise that this orbit, crowded as it is, represents the bridge between what we were and what we might become. This is the proving ground of civilization, our collective learning curve. Each fragment of debris is a lesson written in metal. Be careful with your miracles. You let yourself drift among the relics a little longer, surrounded by the faint glint of human invention. Above, space yawns wider, darker, quieter. Ahead lies emptiness untouched by satellites, untouched by humanity's fingerprints. You take one last look at the silver ring of debris encircling Earth and whisper softly to yourself, "We've built a halo and cluttered it too." You leave the crowded hum of low Earth orbit behind, gliding farther from the swarm of satellites and debris. The noise of civilization fades into an eerie calm, replaced by the slow pulse of gravitational music. Space feels wider now. Emptier, yes, but cleaner somehow, as if you've stepped beyond the clutter of human fingerprints. The planet still looms behind you, round and radiant, its blue glow softening into a pale shimmer. Ahead, there is only darkness, a darkness that stretches towards something you can't quite name. This is the region where Earth's pull begins to fade, a boundary not of atmosphere or magnetism, but of ownership. You've reached the hill sphere, the invisible bubble that marks where Earth's gravity finally stops calling the shots. You can't see the boundary, of course. Gravity isn't a wall, it's a persuasion. It doesn't vanish, it just loses the argument. Inside this zone, about 1.5 million kilometers wide, Earth's pull dominates. Beyond it, the sun takes over. It's a cosmic custody arrangement. Everything here still belongs, technically, to Earth. Satellites, the moon, and even a handful of asteroids caught in temporary orbits. Earth's extended family, all tethered to this gravitational domain. The moon, your silent companion tonight, glides gracefully along its path near the edge of this bubble, its pale face half lit by the sun. It's been orbiting for 4.5 billion years, ever since a violent collision tore it from Earth's side. Historians still argue whether that impact was a single catastrophic event or a slow mergings of multiple protoplanets. Either way, the moon has been circling ever since, forever close yet forever apart. You drift closer to it now, watching as craters sharpen in the light. The surface looks soft from afar, but jagged up close, carved by the scars of countless collisions. The moon, like Earth, bears the evidence of time's violence, but without an atmosphere, nothing fades. Footprints left by astronauts half a century ago remain untouched, preserved in powdery regolith. The thought is oddly haunting, a moment of human history frozen for eternity. You picture Neil Armstrong's famous words echoing across a landscape that cannot echo back. He stepped into silence so vast that sound itself refused to travel. You pass over the Terminator, the line between lunar day and night, where shadows stretch for miles. The sunlight here is merciless, unfiltered, ancient. You imagine the Apollo crews squinting under their visors, every motion clumsy in low gravity, every heartbeat amplified by the knowledge that one misstep meant no return. The moon has always been humanity's rehearsal for leaving home, a cosmic training ground. And even now, as new space programs plan to return, the question lingers. Did we ever truly leave, or did we just pause to catch our breath? Farther from the moon, the gravitational tug of Earth and Sun begins to wrestle. You can almost feel the tension, the push and pull of celestial loyalties. There are 5 points where their forces balance perfectly. Known as Lagrange points, little pockets of stability where gravity and motion cancel each other out. At one of them, L1, about 1.5 million kilometers sunward, sits the Solar and Heliospheric Observatory, SOHO, endlessly watching the sun. At another, L2, sits the James Webb Space Telescope, floating in Earth's shadow, peering into the oldest light of the universe. You pass through that region in imagination, seeing the telescope's golden hexagonal mirror gleaming faintly in starlight, quietly unfolding the secrets of creation. It's strange to think that such delicate machinery can sit motionless in such a vast, violent place, balanced perfectly on the knife edge of gravity. A small laugh escapes you. It feels almost unfair how serene it looks. Humanity, clumsy and chaotic on Earth, somehow built a device that can balance between gravitational giants and gaze calmly into eternity. If that isn't poetic, nothing is. As you drift farther from Earth's gravitational sphere, the sun's pull starts to dominate. It's subtle, like being caught in a new current. You've moved from being an Earthling to becoming officially a citizen of the solar system. It's a milestone no spacecraft can announce with a ping or flash. It's simply a quiet shift in allegiance. The moon still follows Earth, and Earth still follows the sun. Everything orbits something else, and nothing is ever truly alone. You pause to consider how scientists first calculated these cosmic boundaries. In the 18th century, Joseph Louis Lagrange, the French-Italian mathematician who gave the balance points their name, discovered that the gravitational forces between two large bodies could create equilibrium zones. Historians still argue whether he realized how profoundly his equations would shape modern astronomy. His math predicted the quiet places where spacecraft could rest, but also where dust and asteroids might collect, like crumbs trapped in a spinning bowl. You imagine him, hunched over parchment centuries ago, sketching equations that would one day determine where telescopes float. It's oddly comforting, knowing the universe follows the same math now as it did then. The silence around you deepens, though silence feels inadequate to describe it. It's not the absence of sound, it's the absence of interruption. Even light seems more deliberate here. Every photon travelling in straight, patient lines. You begin to sense how vast gravity's web truly is, how far the Earth's influence stretches, and how it blends seamlessly into the sun's. There is no real line, just an ever-weakening hold. You can't help but think of spacecraft like Voyager 1 and 2, which left Earth decades ago, and are now drifting in the interstellar dark. When they passed the boundary of the sun's domain, the heliopause, scientists celebrated as if humanity itself had crossed into myth. And yet, even those distant travellers still feel the faint pull of home. Gravity doesn't stop caring, even when distance tries to make it forget. You look back once more. Earth is now a glowing dot beside its silver moon, the pair orbiting each other like dancers in slow motion. You can barely see the shimmer of the magnetosphere, the faint haze of atmosphere. You think of everyone you've ever known, all of human history contained within that fragile speck. The realization makes you both small and infinite at once. You drift onward, leaving the hill sphere behind, your invisible tether stretching thinner with every moment. Ahead, the sun waits, patient and powerful, holding every planet in its light. You're leaving Earth's home field, but you're not leaving its story. The gravity that held you still whispers, "Come back when you're ready." The sun fills your vision now, a furious golden sea boiling against blackness. You're far enough from Earth that home has shrunk to a single glint of blue light, a punctuation mark orbiting the edge of radiance. Here, in the vast gulf between worlds, you finally understand that the solar system isn't a collection of planets. It's an atmosphere in its own right. The sun breathes, and that breath fills everything. It's not air, it's plasma, a river of charged particles that races outward in every direction, shaping an invisible domain that reaches far past Pluto. You've entered that current. You can feel it even now, the faint hiss of energy brushing your skin like a soft electric wind. The solar wind, as it's called, is both life and threat. Without it, Earth's magnetosphere wouldn't shimmer, auroras wouldn't dance, and the planets wouldn't be gently sculpted by its touch. But too much of it and electronics fry, atmospheres erode, and spacecraft drift helplessly through invisible storms. The sun is the ultimate multitasker, creator and destroyer in one. Every second, it ejects billions of tons of plasma, a constant exhalation that never stops. The sheer scale is absurd. Even if you could scoop up 1 second's worth of solar wind, it would weigh as much as the Great Pyramid of Giza. Historians still argue whether the first scientists to theorize this cosmic breeze in the mid-20th century truly grasped how vast it was. Eugene Parker, who proposed it in 1958, was mocked at first. His papers nearly went unpublished. A few years later, spacecraft confirmed every word. Today, a probe bearing his name, Parker Solar Probe, is flying through that very wind, daring to touch the sun's outer atmosphere. You drift inside that invisible breath. It doesn't feel like wind in any earthly sense. There's no resistance, no pressure, just a faint prickling energy, a sense of motion that doesn't belong to you. The solar particles are sparse, fewer than a handful per cubic centimetre, yet they move at hundreds of kilometres per second. You watch them glide past in streaks of light your mind imagines but your eyes cannot see. Somewhere behind you, Earth's magnetosphere catches a fraction of them, bending and deflecting the rest. Without that protection, the solar wind would strip away oceans and air like sand from a dune. It's happened before. Mars is living proof. Your gaze turns toward that small red planet now. From here, its colour is muted, more ember than crimson, but its silence speaks volumes. Billions of years ago, Mars may have had rivers, even seas, but when its molten core cooled and its magnetic field faded, the solar wind swept in like a thief, stealing the air molecule by molecule. The planet's story is written in its scars, dry valleys where rivers once sang, canyons deeper than Everest is tall. You imagine standing there, the sun twice as bright and twice as deadly, its radiation unfiltered. Historians still argue whether Mars ever hosted life or merely the ingredients for it, but either way, the sun's breath ended the experiment early. You can almost feel the melancholy in that thought, creation undone by the same force that made it possible. You turn back toward the sun, hypnotized by its seething light. Its surface, if you can call it that, is a roiling mass of convection cells, each the size of continents. The outer atmosphere, the corona, stretches millions of kilometers into space, hotter than the surface itself, though no one fully knows why. Some blame magnetic reconnection, lines of magnetic force snapping and rejoining like cosmic rubber bands flinging energy outward. Others suspect waves of plasma resonating through the sun's outer layers. Historians still argue which explanation fits best, though every probe seems to suggest there's always more to learn. You decide that's comforting. Even the most studied object in the sky still keeps secrets. A faint hum seems to surround you, not sound but vibration, the trembling of charged particles against space itself. If you could translate it, it would be a song. The music of solar oscillations, rhythms that scientists record and analyze like heartbeats. Every pulse, every flare, every coronal mass ejection is a note in that endless symphony. The sun has been playing it for 4.6 billion years, and it will continue for billions more, until it swells into a red giant and devours the inner planets. You can almost imagine the final crescendo, a slow, majestic farewell performance. You watch as the solar wind continues outward, brushing against planets, moons, asteroids. It carries the sun's fingerprints across the entire solar system, a constant reminder of origin. It's strange to think that every atom in your body, every bit of carbon, calcium and oxygen, was forged by a star like this one. You're literally made of solar ash, reassembled into consciousness. The realization hits you quietly. When you drift through the solar wind, you're not visiting it, you're returning to it. Somewhere far beyond Neptune, that wind begins to slow. It meets the thin, cold gas between stars and forms a vast bubble called the heliosphere. Within it lies the sun's domain, everything bathed in its breath. Voyager 1 crossed that boundary in 2012 after 35 years of travel, becoming the first human-made object to touch the interstellar medium. Even now, it sends back faint whispers, data pulses that take more than 20 hours to reach Earth. Each signal is a time capsule, a postcard from the frontier. You think about that tiny spacecraft, powered by a fading plutonium core, still dutifully calling home across light years. There's something heartbreakingly loyal about it. Your mind drifts to a quirky tidbit, how Voyager carries the golden record, a phonograph filled with sounds and images of Earth. Greetings in dozens of languages, the sound of rain, a mother's kiss, whale songs, Bach, Chuck Berry. It's humanity's mixtape for the cosmos, launched in hope that someone or something might one day find it. Historians still argue whether it was hubris or poetry. You decide it was both, which makes it perfectly human. The solar wind rushes past you again, endless and restless. You realize the sun isn't a static ball of fire, but a breathing organism, expanding and contracting in eternal rhythm. Its light touches every corner of its kingdom, the asteroid belt glittering faintly, the gas giants wearing their rings like crowns, Pluto orbiting shyly at the edge. Each world lives within this single breath, warmed or burned by its touch. You can feel the faintest pull forward, the momentum of the wind carrying you outward. Behind you, the planets trail in perfect order, tiny beads on invisible strings. Ahead, the boundary of the sun's empire waits, the place where this wind finally surrenders to the interstellar night. You take one last look at the golden star, its light so fierce it carves shadows into your thoughts. It doesn't feel distant anymore. It feels personal, like an ancestor you've only just recognized. You whisper into the silence, though there's no air to carry the sound. Thank you for the light. You've been riding the sun's breath for what feels like days, though here time has stopped meaning anything. There's no sunrise or sunset anymore, only a steady blaze behind you and an infinite star-filled quiet ahead. The solar wind has thinned now, slowed by its own distance, meeting resistance from something you can't see. The airless dark feels heavier somehow, denser. You've reached the frontier, the heliopause, the very edge of the sun's influence. It's not a wall, but a transition, a cosmic shoreline where solar particles crash into the interstellar medium like waves meeting another ocean. Beyond this point lies true interstellar space, a place no sunlight rules. You pause in that silence, hovering at the border. It's oddly peaceful, though everything here is in constant motion. You can almost hear the soft hiss of particles colliding, a kind of static symphony marking the boundary between two domains. It's humbling to realize that this invisible border defines our cosmic neighborhood, the place where our sun's atmosphere ends and the galaxy begins. You imagine tracing its shape, a vast bubble roughly 18 billion kilometers wide, enclosing every planet, comet, and spacecraft ever launched. That entire expanse, all of human exploration, fits inside this single glowing membrane. Voyager 1 crossed this frontier in 2012. Its twin, Voyager 2, followed in 2018. They are the first messengers to leave the heliosphere entirely. When their instruments recorded the shift, the drop in solar particles, the rise in cosmic rays, scientists back home cheered and wept. Humanity had officially stepped beyond the sun's protection. Historians still argue whether that moment marked the beginning of interstellar travel or merely the final page of the space age's first chapter. Either way, the boundary became real that day, not as an idea, but as a measurement. You imagine Voyager drifting somewhere ahead of you now, a small summit speck of aluminum and memory, its antennas still turned toward the distant glimmer of home. Its power is fading. By the 2030s, it will fall completely silent, carrying its golden record through eternity. Somewhere out there, it moves at nearly 17 kilometers per second, fast enough to cross the continental United States in 4 minutes, yet hopelessly slow against the vastness of the galaxy. It's an eternal paradox, moving faster than anything human, yet going almost nowhere. You drift closer to the boundary itself, feeling the shift between regions. On one side, the solar wind still flows outward, though weakly. On the other, cosmic rays from distant supernovae press inward. Where they meet, turbulence reigns, a storm of magnetic fields colliding in chaotic beauty. It's like standing in the surf between two oceans, each wave insisting it's in charge. You can almost sense the tension, the push and pull of forces older than Earth itself. The heliopause isn't a hard edge, it breathes. When the sun's activity increases, the boundary swells outward. When it quiets, the bubble shrinks. It's a living frontier, always shifting, always uncertain. You turn and look back at the sun. It's smaller now, a pale gold coin burning against the black. The planets you passed, Mercury, Venus, Earth, Mars, the gas giants, are invisible to the naked eye, their orbits folded into the darkness. The solar system feels both enormous and small, a self-contained miracle adrift in the galaxy's sea. You think about how all this energy, all this life depends on one star's breath. The heliopause is simply where that breath ends. Everything beyond it answers to other stars, other winds. It's strange to think that this invisible border, this shell of plasma, marks the true edge of our sun's empire. The word empire feels dramatic, but it fits. Within this domain, the sun's light dominates. Outside, other stars rule. It's a cosmic patchwork of sovereignty, each bubble colliding softly with its neighbours, forming an unseen web of stellar influence. You realise, with a kind of sleepy wonder, that the galaxy isn't a cold vacuum. It's a field of overlapping breaths. A faint signal flickers nearby. imaginary maybe, or memory. You picture Voyager again, still transmitting across the dark. The data it sends takes more than 22 hours to reach Earth now. By the time scientists receive each pulse, the spacecraft has already moved millions of kilometers farther away. Communication feels like talking to a ghost who always answers a day late. And yet that conversation continues. Humanity refuses to hang up. There's something beautifully stubborn about that, our need to stay connected, even when the delay stretches into forever. You remember reading about a strange discovery. As Voyager 1 crossed the heliopause, its instruments detected an unexpected hum, a faint plasma vibration filling the interstellar medium. It was constant, almost musical. Historians still argue about its origin. Could it be a natural resonance of space itself, or the dying echo of the solar wind still whispering into the void? You decide it doesn't matter. The universe hums because silence perhaps is too lonely. You glance outward now, past the boundary. The stars seem sharper, somehow more real. The light feels colder, unfiltered by the sun's influence. You're looking at the same stars Voyager sees, the same constellations your ancestors used to map their myths. Every culture, every time has stared at this sky and wondered where it ends. You're closer to that answer than anyone before you, and still it stretches farther than comprehension. A small chuckle bubbles up from somewhere deep inside. You remember the phrase leaving the solar system, as if it were a finish line. In truth, it's just the beginning of a larger ocean. The sun's glow may fade behind you, but its presence lingers, like the sound of waves long after the tide has gone out. As you drift through the heliopause, the plasma around you grows thinner still. The particles here are ancient, untouched remnants from the birth of the galaxy. Each one carries history, atoms that may have once belonged to dying stars, drifting endlessly between systems. You think of them as whispers from strangers you'll never meet. Behind you, the heliosphere still gleams faintly, a fragile bubble protecting its fragile worlds. Ahead, the galaxy yawns open, billions of suns, each with their own invisible borders, each exhaling their own breath. You realize that the edge of space isn't a line at all. It's a conversation between stars, carried on forever in the wind. You take one last look back at the faint golden shimmer of your home star, its light trembling across eternity. The sun doesn't look like a god anymore. It looks like a heartbeat, steady and small in the dark. You whisper a soft thank you, then turn toward the deeper night. The heliopause glows behind you like a candle's flame caught in glass, flickering as you drift beyond the reach of warmth. The darkness changes again, showing less empty now, though it's hard to say why. You're adrift in a vast, faintly glowing gulf of gas and dust, a region shaped long before the sun was born. The stars around you are brighter here, but their light feels filtered through something thin and hot, like air above asphalt. You've entered what astronomers call the local bubble, a cosmic cavity in the Milky Way's interstellar medium. It isn't empty. It's filled with plasma so thin you could travel 100 kilometers before hitting a single atom. And yet that almost nothing stretches for hundreds of light years in every direction, a reminder that even emptiness has history. You drift through this invisible expanse as if gliding through memory. The local bubble, scientists say, was carved out by a chain of supernovae, massive stars that exploded between 10 and 20 million years ago. Their blast swept interstellar gas aside, leaving behind this hollow pocket surrounded by walls of denser material. You picture those detonations, brief suns blooming and dying in cosmic silence, their shock waves overlapping like ripples on a pond. Each one seeded the future with heavy elements: iron, gold, calcium, the stuff of planets, bones, and jewelry. Historians still argue whether our own sun was born from that same wave of destruction or wandered into the cavity later, a tenant who moved into a house already burned down. Either way, you're living proof that chaos can be creative. If you could see the bubble's edge, it would look like a translucent shell glowing faintly in soft X-rays. The walls are hundreds of light years thick, dense clouds of hydrogen and dust where new stars are forming. You can almost sense their warmth, those nursery fires hidden behind the veil. The local bubble isn't alone either. It bumps and merges with neighbouring cavities, each one a footprint of long-dead stars. Together they make the galaxy look like cosmic Swiss cheese, a web of voids and filaments, evidence of endless creation and collapse. A small spacecraft flickers through your imagination, the European Space Agency's Gaia Observatory, which mapped our corner of the galaxy with exquisite precision. Using its data, astronomers traced the outlines of the local bubble for the first time, realizing that many of the young stars near us, like those in the Pleiades and Scorpius-Centaurus associations, sit right on its surface. They are literally born from the edges of old explosions. You think about that, how the deaths of ancient giants paved the way for new suns, how destruction built a cradle. There's a strange comfort in that kind of recycling. The environment here is harsh but beautiful. The plasma temperature hovers around 1,000,000 degrees Celsius, yet the density is so low that a thermometer would barely twitch. It's like standing in an oven made of ghosts. Cosmic rays dart through the emptiness, charged particles accelerated by distant supernova remnants. Every so often one of them passes through you, a silent, invisible traveller that's probably older than humanity itself. You realise that these rays are the universe's storytellers. They carry the chemical fingerprints of their birthplace across unimaginable distances. You think about the human instruments that have measured them. In 1912, Victor Hess discovered cosmic rays by sending in a balloon over Austria, armed only with an electroscope and a questionable sense of self-preservation. His instruments showed increasing radiation with altitude, proving that something from space was raining down constantly. Historians still argue whether his flight was bravery or madness. Considering the thunderstorm he flew through, perhaps both. Thanks to him, we now know that every second billions of cosmic rays pass through our bodies, proof that space doesn't really stop at our atmosphere. It has always been visiting us. You drift deeper, and the scale begins to distort your sense of movement. Distances here are measured in light years, but your thoughts still insist on human meters. You picture yourself shrinking until even atoms look enormous. Within that mental shift, you begin to feel the local bubble not as emptiness but as structure, a breathing lung of the galaxy, expanding slowly, interacting with its neighbours. You imagine two bubbles colliding, their walls folding and mixing, shock fronts sparking new clusters of stars. In a way, every sunrise back on Earth began in such a collision. A streak of light flares briefly in the distance, a supernova remnant still glowing after millions of years. Its delicate filaments remind you of hope frozen in time. If sound could travel here, the explosion would have been a roar louder than imagination. But all that energy passed into silence instead. The remnant expands at a pace so slow, it looks motionless, yet its reach spans light years. The scale of everything around you makes even eternity feel small. A quirky thought drifts through your head. If the local bubble were filled with air at Earth's pressure, it would weigh more than 10 billion suns. Instead, it's almost nothing, proof that nothingness can still dominate everything. The paradox makes you grin. Space loves irony. The sun sits somewhere near the bubble's inner edge, moving through it at roughly 26 kilometers per second. It drags the entire solar system along like a caravan crossing an ancient desert. Occasionally we pass through patches of denser material, interstellar clouds that slightly distort cosmic rays and affect the heliosphere's shape. Scientists track these crossings using dust grains that fall into the solar system. Historians still argue whether such encounters could influence Earth's climate or radiation levels. The idea is fringe but oddly romantic, the notion that our planet's history might be punctuated by the geography of the galaxy itself. You let the idea settle, feeling very small but also connected. Every atom in you, every breath you've ever taken was once part of some older star's death decree. The local bubble is a reminder of that lineage. You're not just passing through the aftermath of explosions, you are their aftermath, walking proof that the universe recycles everything, even curiosity. As you drift near the faint wall of the bubble, the light grows slightly denser, a golden haze against the void. Beyond it lie other regions, other shells, places with names that sound almost mythic. The Lupi superbubble, the Perseus-Taurus cloud, the Orion-Eridanus cavity. Each one has its own story, its own pattern of birth and decay. You realise that space doesn't stop anywhere, it just changes texture. Every void is bordered by creation. Every silence hums with potential. For a long moment you simply float and listen, not with ears, but with imagination. You picture the aftershock of ancient stars still rippling around you, moving slower than any tide, carrying fragments of the past into futures that haven't been written yet. Somewhere within that endless resonance, your own sun hums quietly, one small voice in a cosmic choir of fire and dust. You drift through the glowing haze of the local bubble, expecting it to thin into nothing, but nothing in space ever truly becomes empty. Even here, far beyond the reach of the sun's wind, the void hums with quiet persistence. The darkness ahead isn't pure, it's speckled with dust grains, drifting atoms, orphaned molecules of hydrogen and helium, and the occasional rogue wanderer, a planet without a star. You've entered the interstellar medium, the space between spaces, the vast connective tissue of the galaxy. From afar, it looks like nothing. Up close, it's everything that fills the silence. The emptiness here is deceptive. A single cubic meter of interstellar space might contain only a few atoms, yet stretched across light years, those atoms add up to immense masses. You could call it the galaxy's bloodstream, carrying elements forged in supernovae through endless night. Each particle you pass is a relic, older than any world you've seen. It's strange to think that the darkness isn't absence, it's heritage. You float through this mist and feel an odd familiarity, as though drifting through air underwater. Faint glows shimmer in the distance, nebulae, those vast clouds where stars are born. Some are bright, lit by the radiation of the nearby suns, others are dark, hiding their light within. You imagine reaching into one, brushing your fingers through cosmic dust so fine it could pass through your skin. The grains here are mostly silicates, carbon, ice, tiny versions of the same ingredients that built Earth. Historians still argue whether life on our planet began with such dust, carried by comets or meteors. It's a theory called panspermia, and though controversial, it's almost poetic. Life scattered like seeds, waiting for the right planet to bloom. A rogue planet tumbles past, a lonely frozen sphere drifting without a sun. Its atmosphere, if it has one, clings weakly to its surface, shimmering faintly under distant starlight. Astronomers believe there may be billions of such worlds in our galaxy, ejected from their birth systems by gravitational chaos. Homeless, wandering, they carry the ghost of the stars that made them. You can't help but feel a kinship with it, this planet that belongs nowhere but still moves forward. You remember reading that in 2011, a team of scientists detected the first confirmed rogue planet, known simply as CFB-DSSR 21490403, a name that sounds less like poetry and more like a Wi-Fi password. Historians still argue whether it's truly free-floating or still faintly bound to a distant star. That ambiguity seems fitting. Out here, nothing is absolute. Boundaries blur, definitions bend, space doesn't end, it drifts. The light around you dims, but the stars themselves grow sharper. Their distance is measurable only in imagination. You notice faint wisps of colour, hydrogen clouds glowing crimson under ultraviolet radiation, delicate veins stretching across the dark. These are the emission nebulae, places where new suns gestate in silence. Elsewhere, thick black patches block the starlight entirely. Dark nebulae, dense pockets of gas so cold and rich that gravity might soon coax them into forming stars. You realise the galaxy isn't static, it's breathing. Every collapse, every explosion, every drift of dust is part of a rhythm older than time itself. A tiny sparkle flashes past your peripheral vision, an interstellar grain of dust colliding with another, fusing in a brief dance. Multiply that by trillions, and you get the birth of planets, comets, moons. You're witnessing creation in slow motion. It's humbling and oddly intimate. Like watching the universe knit its own skin. You think of the Voyager spacecraft again, now somewhere behind you, still swimming through this same sea. When its instruments first detected interstellar plasma vibrations, scientists described them as gentle hums. You like that phrase, it sounds like the universe softly exhaling. Maybe that's what this medium really is, not emptiness, but the quiet breath of the galaxy itself. A quirky thought crosses your sleepy mind. If someone could bottle interstellar dust, what would it smell like? Astronauts on the ISS often say that space has a scent, burnt metal and raspberries, oddly enough. The molecule responsible for that fruity note, ethyl formate, has been detected in giant molecular clouds. Historians still argue whether the smell is real chemistry or psychological suggestion, but you decide you'd prefer to believe the universe smells faintly of dessert. You drift onward, tracing invisible filaments of hydrogen that link one nebula to another. Somewhere nearby, two interstellar clouds are colliding, triggering a burst of star formation. The process is violent but productive, shockwaves compressing gas until gravity takes over. You picture it like kneading dough, cosmic hands folding and pressing until stars ignite. Each newborn star will someday forge heavier elements, explode, and scatter its remains to start the cycle again. Creation through destruction, space's favourite trick. You remember reading about the Orion Nebula, visible even to the naked eye from Earth. It's one of the few places where humans can actually see this process happening. Inside it, thousands of young stars blaze, surrounded by disks of dust that may one day become solar systems. You imagine hovering there, watching suns ignite like candles in a cathedral of gas. Historians still argue whether our own solar system formed in a similar region, bathed in the radiation of nearby giants. The evidence suggests yes. The traces of certain isotopes in meteorites point to the fingerprints of a long-dead supernova. You find that comforting somehow, knowing that even destruction leaves gifts behind. The space between stars feels lonely but not lifeless. Invisible waves of radio emission pulse all around you, signals from quasars, pulsars, and distant galaxies. You can't hear them, but you sense their presence, each one a heartbeat from somewhere unimaginably far away. To the untrained eye, it's chaos. To a scientist, it's music. The universe sings constantly, you just have to know how to listen. You drift through a cluster of microscopic ice crystals, remnants of a comet that once passed through this region millions of years ago. They sparkle faintly, catching starlight like falling snow. For a moment, it feels like home, like winter on an impossible scale. You reach out, and one flake passes harmlessly through your hand, leaving behind nothing but the sensation of cold memory. The thought occurs to you, maybe space never stops because it doesn't need to. It's not a place with borders, it's a process, an endless circulation of matter and energy. Dust becomes stars, stars become dust, and everything in between keeps moving. The idea feels both dizzying and soothing. Infinity isn't something to reach, it's something to recognize. You glance back toward the faint dot of the sun glowing like a spark inside the local bubble. Around it, the planets trace their invisible circles, oblivious to the vastness beyond. You've come so far that home no longer feels like a point on a map, it feels like a story told by light. You drift onward, past invisible clouds, through silence thick with history. Ahead lies the edge of the Milky Way's spiral arm, where starlight begins to thin. The interstellar medium fades gently, giving way to something grander, the rim of the galaxy that has no rim. You take a breath that doesn't exist, smile faintly, and continue forward. The stars aren't getting closer or farther, they are simply there, infinite and indifferent, waiting to be named. You've been drifting for so long that distance itself starts to lose meaning. The sun is a pinprick now. The local bubble behind you a faint, invisible breath against the dark. Ahead, the galaxy stretches in every direction, an ocean of stars swirling in a luminous spiral. You're heading toward its outer regions now, where starlight grows sparse and the Milky Way begins to fade into its own shadow. This is the edge of the galaxy, though the word edge feels almost dishonest. There's no line here, no cliff to fall from, just a gradual thinning of stars like sand scattering at the lip of a dune. You pause in the slow drift and take in the scale of it all. The Milky Way is vast, over 100,000 light-years across, and you're floating near the outskirts of one of its spiral arms, the Orion Arm, where the stars grow fewer and colder. You can see the galaxy's central bulge faintly glowing far behind you, wrapped in delicate ribbons of dust. Its light takes tens of thousands of years to reach this place, meaning you're watching a past that Earth hasn't even begun to imagine yet. Historians still argue whether our ancestors first saw the hazy band of the Milky Way as dust, fire, or divine pathway. The Greeks called it Galaxius Kyklos, Milky Circle. The Maya called it the World Tree. The Chinese saw it as a celestial river separating two lovers, the cowherd and the weaver girl, who could meet only once a year when magpies formed a bridge of wings. You smile at that last one. It's nice to think even the galaxy needs romance. Here, the stars thin out until they're surrounded by darkness so deep it almost looks like velvet. You notice something subtle. Most of the stars near you are smaller, cooler, redder. These are the galaxy's elders burning slowly, quietly, like fading embers. The younger, brighter ones huddle closer to the galactic center, where gas and dust are still abundant enough for new creation. Out here, things age gracefully. The pace is slower. Even light seems reluctant to leave. You catch sight of a globular cluster hanging nearby, a dense sphere of ancient stars orbiting the galaxy like a satellite. It contains hundreds of thousands of suns, all packed so tightly that their combined gravity keeps them bound together for billions of years. Each one is a relic from the galaxy's youth. The oldest clusters, like M13 and Hercules, formed nearly 12 billion years ago, before Earth existed, before the Milky Way even finished assembling itself. Historians still argue whether these clusters were once small galaxies the Milky Way absorbed, or simply the galaxy's first building blocks. You drift through their light, feeling like a time traveler gliding through the memories of creation. The further out you go, the more visible the halo becomes, a nearly spherical region of dark matter and stray stars surrounding the galaxy. The stars here are sparse, lonely wanderers pulled by invisible gravity. You can't see the dark matter itself, of course, but you can sense its influence. It bends the paths of galaxies, holds the Milky Way together, shapes everything yet remains utterly undetectable except through its pull. Scientists estimate that dark matter makes up about 85% of the galaxy's mass, yet no one knows what it is. Historians still argue whether it's made of undiscovered particles, primordial black holes, or something stranger, an illusion caused by flaws in our understanding of gravity itself. Whatever it is, it's working. Without it, the stars you see would fly apart like sparks from a dying fire. You find the mystery soothing. There's comfort in not knowing everything. You imagine the galaxy wrapped in an invisible hug, held together by something sondant and patient. You can almost feel that gravity now, a faint tug, not toward the sun anymore, but toward the Milky Way's collective mass, a pull from everywhere at once. A flicker passes across your vision, faint but sharp. It's a stellar stream, a ribbon of stars stretching across space, remnants of an ancient dwarf galaxy that the Milky Way consumed long ago. Dozens of such streams crisscross the halo like scars, traces of cosmic cannibalism. The galaxy, for all its grace, is a predator too. Every few 100 million years, it swallows smaller galaxies whole, absorbing their stars and scattering the rest. You remember reading that our own galaxy is currently devouring the Sagittarius dwarf galaxy, its stars wrapping around the Milky Way like a ghostly spiral. Historians still argue whether the Sagittarius dwarf will survive another orbit or dissolve completely. Either way, it's proof that even in space, survival and assimilation are part of the same story. You drift past a dim red star, one of the countless M-dwarfs that dominate the galaxy. They're tiny, cool, long-lived, burning for trillions of years, long after our sun is gone. Some may host planets, quiet worlds bathed in gentle crimson light. You wonder what sunsets would look like there, if anything alive ever looked up to see them. Astronomers have already found several such worlds. Proxima Centauri b, TRAPPIST-1e, tiny orbs circling small red stars. Each one sits in the habitable zone, that delicate band where liquid water could exist. Historians still argue whether any of them harbour life, but statistically, the odds are almost certain. Somewhere, in some quiet orbit, another sky is watching its own stars fade. A streak of faint green light catches your eye, the glow of cosmic rays colliding with a dust cloud. It reminds you of an aurora, though there's no atmosphere here to paint one. The galaxy is full of such illusions, tiny echoes of beauty scattered through danger. You remember that even out here, beyond the familiar spiral arms, there are still a few rogue wanderers, planets, asteroids, even the occasional comet flung from the outer solar system. Some of them may have been travelling for billions of years, never finding a home, carrying secrets from their birth systems like bottled messages adrift in eternity. As you drift farther from the galactic disk, you glance back one last time. The Milky Way spreads before you like a river of diamonds flowing through velvet. The core glows amber, the spiral arms shimmer blue and white, dark dust lanes weave through like rivers of shadow. You've seen photographs of this view, taken by telescopes, but they never capture the motion, the subtle rotation that makes the whole structure feel alive. It turns once every 230 million years, so slowly you'd never notice, yet you feel its rhythm in your bones. You let the sight fill you completely. This is your home, Not Earth, not even the solar system, but this entire galaxy, one luminous swirl among billions. You think of the dark matter halo holding it together, the ancient clusters circling its core, the streams of swallowed galaxies twining through its outskirts. The Milky Way is both predator and cradle, both memory and momentum. And even here, where the stars finally thin into darkness, space still doesn't stop. Beyond this faint border, between galaxies, lies a new kind of silence, the deep intergalactic dark, where hydrogen atoms drift like forgotten prayers. You take a slow, imaginary breath and prepare to cross again, leaving one infinity for another. You drift away from the last faint shimmer of the Milky Way, watching it diminish behind you until it becomes a luminous ribbon, delicate and curved, like a smoke ring suspended in eternity. You expect emptiness beyond it, blank absolute nothing, but that's not what could greet you. Instead, the space between galaxies reveals itself as a paradox, thinner than a whisper, yet never truly void. You've entered the intergalactic medium, that tenuous expanse of particles and faint light stretching for millions of light years between galaxies. It's the loneliest territory in existence, and yet, everywhere you look, there's evidence of connection. From this vantage, the Milky Way is no longer a home but a neighbour, one glittering spiral among many. The Andromeda Galaxy looms in the far distance, a faint smear of silver light 2.5 million light-years away. To the naked eye from Earth, it was once a tiny blur. From here, it's magnificent, vast, structured, quietly drifting closer. You can almost feel the tension between our galaxies, a mutual gravitational pull that will one day draw them together. In about 4 billion years, the Milky Way and Andromeda will collide, merging into a single elliptical supergalaxy. Historians still argue whether to call that future behemoth Milkomeda or something less ridiculous. Either way, the stars themselves will rarely touch. There's too much emptiness between them, but their gravitational dance will reshape the night sky forever. For now, though, the two galaxies remain apart, moving through a sea of atoms so sparse you could travel light years before hitting one. The intergalactic medium averages just 1 hydrogen atom per cubic meter, practically nothing, and yet across such distances that nothing becomes everything. It fills the cosmic void with faint filaments of gas, invisible but real, stretching between galaxies like nerves between thoughts. Scientists call this structure the cosmic web, a network of intergalactic filaments through which matter, energy and history flow. You're gliding through one of those threads right now, an invisible current connecting worlds you can't even see. The silence here feels heavier than before. There's no magnetosphere, no solar wind, no stellar radiation strong enough to hum in your ears. The temperature hovers just above absolute zero and light travels unbothered for eons. Still, there's motion all around you. Thin rivers of ionized gas drift past, relics of ancient galaxies torn apart by gravity. Their faint glow comes from collisions between atoms so rare they occur perhaps once per century in a given cubic mile. But over millions of years, that's enough to light the void. You turn slowly, trying to absorb the sight. Far behind, the Milky Way glows softly. Ahead, a chain of faint galaxies stretches like beads on a thread. The nearest of these is the Triangulum Galaxy, smaller than Andromeda, but still sprawling across tens of thousands of light years. Between you and it lies pure distance, dark, immeasurable, patient. The scale hurts to think about. Even light, tireless and relentless, would take millions of years to bridge this gap. You realize you're seeing these galaxies not as they are, but as they were before humans existed. Every glimpse of the universe is a message from the past. It makes you wonder what's filling all this nothing. Astronomers say most of the universe's baryonic matter, the ordinary stuff that makes up stars and planets, is actually out here floating invisibly in intergalactic space. It was blown out of galaxies long ago by supernovae and black hole jets, forming hot diffuse halos around galactic clusters. Without telescopes sensitive to X-rays and ultraviolet light, we'd never know it was there. Historians still argue whether early cosmologists expected the universe to be this messy. They imagined galaxies as tidy islands of matter. Instead, they found archipelagos spilling into one another. You drift past a faint wisp of this gas, watching it shimmer as stray cosmic rays excite its atoms. It looks like fog made of light, and for a moment, you You can almost imagine touching it, but there's nothing to touch, just energy moving through vacuum. You feel yourself slowing, though there's nothing to slow against. The only reference you have is starlight itself, and even that seems to move reluctantly here. Somewhere nearby meaning a few million light years, a quasar blazes, the heart of a young galaxy where a supermassive black hole devours gas at furious speed. Its light outshines entire galaxies, visible across billions of years. You can't look directly at it. It's too bright, too violent. Quasars are the lighthouses of the universe, warning and welcoming all at once. The first humans to detect them in the 1960s thought they might be alien transmissions, their radio signals so precise and strong. Historians still argue whether that was wishful thinking or simply the thrill of discovery. Either way, the truth, that they were galaxies eating themselves, proved no less wondrous. As you move farther from the galactic plane, the stars behind you fade until the void becomes nearly perfect. And yet, you sense motion everywhere. Galaxies falling toward clusters, clusters toward superclusters, everything pulled by invisible gravity into a dance that spans billions of light years. The emptiness between them is alive with tension, like the pause between notes in a song too large for human rhythm. You think of the local group, the small neighborhood of galaxies your Milky Way belongs to, about 60 members bound together by gravity. Most are dwarfs, faint smudges orbiting the giants. Beyond that lies the Virgo supercluster, and beyond that the Laniakea supercluster, an even greater structure that contains tens of thousands of galaxies. You realize that even this vastness has an edge, not in space, but in influence. Gravity binds these cosmic cities together, but beyond them lies a deeper current, the expansion of the universe itself. Everything is radiating from everything else, stretched by dark energy like dots on an inflating balloon. A stray thought drifts through your sleepy mind. If everything is expanding, is there truly an outside? Or are we all moving within an infinite fabric that's simply making more room? The question lingers, unanswerable but oddly comforting. You glance back again. The Milky Way and Andromeda gleam faintly in mutual approach. You imagine their future collision, their stars merging into a single golden haze. Their black holes spiraling together in a final elegant waltz. Even destruction in space seems choreographed. A smile tugs at you. You realize that space never runs out of metaphors. It's always both terrifying and tender, like a lullaby sung by physics itself. You are between galaxies now in the loneliest place imaginable, and yet it feels peaceful. Hydrogen atoms drift by like wandering thoughts. Photons from distant quasars brush your face like the faintest breeze. You are surrounded by light that has been travelling longer than Earth has existed. Somewhere out there, new galaxies are still forming, even as others fade away. The cycle continues, unhurried. The intergalactic dark isn't the end of space, it's simply the breathing room between stories. You let the thoughts settle, a calm weight in your chest. Out here, silence is not emptiness, it's rest. You drift farther into the hush between galaxies, and something subtle begins to emerge. A faint glow, barely perceptible, threading through the darkness like veins beneath translucent skin. At first, you think it's a trick of imagination, but then you realize this is the cosmic web, the universe's hidden skeleton. From this perspective, it's as if the galaxies you left behind were merely beads strung along invisible threads. These filaments of gas, dark matter, and ancient light connect everything. Bridges of creation spanning billions of light years. It's the grandest structure ever conceived, and you're floating right through it. A mote of awareness moving across the architecture of existence. The web isn't bright in the usual sense. It's illuminated faintly by the glow of distant quasars and by the thin gas within it. Hydrogen so diffuse it barely registers as substance. But when astronomers first mapped it using simulations and deep space surveys, they realized that nearly all galaxies live along these filaments, clustering at intersections like cities along rivers. Between them lie voids, regions hundreds of millions of light years across where almost nothing exists, cosmic deserts surrounded by highways of matter. You can almost feel the scale, the emptiness so vast that light itself seems shy about crossing it. Historians still argue whether this filamentary universe was first suspected by pure intuition or by brute computing power. Some say it began with the CFA redshift survey of the 1980s, when scientists plotted the positions of galaxies and noticed that they weren't randomly scattered, they formed walls, arcs, and sheets, Others credit the 2005 Millennium Simulation, a digital universe that revealed how gravity, dark matter, and time collaborate to weave structure out of chaos. Either way, it proved one profound idea. The cosmos is not a void sprinkled with islands, it's a web. And everything you've ever known is caught inside it. You drift along one of those filaments now. It stretches before you like a faint river of light, slowly curving into the distance. You imagine each glimmer as a galaxy cluster, containing hundreds or thousands of galaxies, each with billions of stars, each star within its own worlds. The numbers should overwhelm you, but instead they calm you. There's order here, however vast. The web hums with balance, gravity pulling inward, cosmic expansion stretching outward, everything in perfect, endless negotiation. You recall how scientists describe these filaments, not solid roads of matter, but patterns of probability sculpted by dark matter. Dark matter, still invisible, still unmeasured directly, is what gives the universe its scaffolding. Without it, your baryonic matter, the normal stuff, would never have clumped into galaxies at all. You try to imagine what the web looks like in dark matter's view. Smooth, elegant curves of gravitational potential, invisible but absolute. It's as if space itself learned geometry and never forgot. Here and there you glimpse faint patches of brightness, galaxy clusters glowing at filament intersections. The Coma Cluster, the Perseus-Pisces supercluster, the Great Wall, names humans gave to tiny corners of the infinite network. The Great Wall, discovered in 1989, stretches over 100 million light-years. Later, astronomers found the Sloan Great Wall even bigger. The largest known structure, the Hercules Corona Borealis Great Wall, may span 10 billion light-years, so immense that it bends our understanding of cosmic uniformity. Historians still argue whether such colossal features should even exist according to current physics. Maybe the universe is more playful with its rules than we give it credit for. You drift through one particularly bright knot, a galaxy cluster where thousands of galaxies whirl around a common center, their combined gravity warping the light from galaxies even farther behind them. You see arcs of distortion shimmering through space, an effect called gravitational lensing. It's both a scientific tool and a work of art, Einstein's equations turned into stained glass. Some of those arcs are the same galaxy seen multiple times, its light bent and duplicated by space-time itself. You realize you're witnessing the universe looking at itself through a hall of mirrors. It's funny to think that humans figured all this out from one small planet, using telescopes and mathematics. They measured the cosmic microwave background, the afterglow of the Big Bang, and saw faint fluctuations, tiny temperature differences that corresponded to the seeds of these same filaments. You can almost see that ancient energy still rippling through the web, like the echo of an origin story that refuses to fade. A stray cosmic ray brushes past you, a relic particle from some long-dead star. You picture it weaving through the web, guided subtly by the magnetic field stretched across unimaginable distances. Even the emptiness hums with invisible structure. Nothing truly drifts alone. Every motion, no matter how small, echoes through the fabric of the whole. You wonder what it would feel like to touch a filament, to feel the gravity of billions of galaxies vibrating through it. Maybe it would be like pressing your hand against a living pulse. Scientists believe that intergalactic gas within these threads accounts for the universe's missing matter, the atoms long suspected but never seen. Recently, with X-ray telescopes, they finally detected its faint glow, a ghostly confirmation that the web is real. Historians still argue whether the discovery solved the mystery completely, but it brought humanity closer to understanding its place in the cosmic architecture. The more you gaze, the more the web begins to resemble something organic. Neurons in a brain, veins in a leaf, the root system of an ancient tree. You think of the old philosophical saying, as above, so below. Maybe the universe repeats itself in every scale, from the microscopic to the galactic. Perhaps the human mind is simply a smaller reflection of this same network, a tiny echo of the structure that holds galaxies together. The idea feels less like science and more like lullaby logic, soothing and infinite. You turn slowly, looking along the glowing threads that connect clusters across billions of years. The sight is hypnotic, everything connected, everything delicate, everything impossibly vast. The web doesn't seem to end, it simply fades into the limits of your perception. The filaments shimmer faintly, fading into black until only starlight remains. Somewhere deep within this framework, on a planet orbiting a modest star inside a spiral arm of one galaxy, someone once asked, "Where does space stop?" You realise the answer isn't out here. It never was. The web continues beyond sight, beyond time, an endless pattern folding and unfolding itself. For now, you float at its centre, suspended in light that has been travelling since before Earth existed, and you whisper to yourself, half in awe, half in surrender, it doesn't stop at all. You can feel the filaments of the cosmic web fading into distance behind you, the glow thinning until even light itself seems uncertain of its purpose. Ahead, the stars shrink into the faintest possible haze, a soft, translucent wall that marks the farthest thing the human eye, or any instrument we've built, can ever see. You've reached the observable limit, the cosmic horizon, the final page of the universe's visible story. Beyond this lies something we can never touch, not because it doesn't exist, but because light itself hasn't had time to reach us from there. You hover at the brink of visibility, where the oldest light still travels and the future can't yet be seen. The universe you're looking at here is ancient light, literally a time machine painted across the darkness. Every photon that hits you has been travelling for billions of years. The galaxies glowing faintly ahead are not how they are, but how they were when the universe was young. You are staring backward across 13.8 billion years of history, all compressed into a thin, shimmering shell. It feels less like distance and more like memory. The light ahead isn't starlight anymore. It's the cosmic microwave background, the afterglow of the Big Bang, a sea of faint radiation that fills all of space. It's everywhere, omnipresent, whispering softly at a temperature just a few degrees above absolute zero. If you could see it with your eyes, it would glow in every direction, perfectly, even except for the tiniest ripples, microscopic differences that became galaxies, stars, and people. Those fluctuations are the fingerprints of creation itself. Historians still argue whether the discovery of that faint background in 1965 by Arno Penzias and Robert Wilson was the most important accidental find in history. The two radio astronomers thought their antenna was just picking up pigeon droppings. Turns out it was hearing the echo of the universe's birth. You drift through this radiation now, feeling the hum of ancient photons brushing across your skin. Each one has been expanding with the universe, stretched from blinding gamma rays into long lazy microwaves by cosmic inflation. Their wavelength has grown with time, like music slowing down over billions of years. The result is a near-perfect silence, energy so low it barely exists, yet without it the cosmos would have no memory of its beginning. You imagine the moment that light was born. The universe was only 380,000 years old, a dense fog of plasma cooling just enough for atoms to form. Before that, light couldn't travel freely. It scattered endlessly in all directions, trapped by a sea of charged particles. But when the fog cleared, the first photons broke free and began their journey outward. Those same photons are what surround you now, the oldest travellers in existence. They've been moving ever since, carrying the story of everything that's ever happened. As you float at the edge of visibility, you notice faint irregularities in the glow, tiny cold and warm patches spread across the sky. They look random, but within them lie the seeds of everything that followed. The slightly denser regions grew under gravity's pull, forming galaxies and clusters. The emptier ones became the cosmic voids. It's staggering to think that all the complexity of the modern universe, the Milky Way Earth-U, was written into those faint ripples like code in a newborn computer. The universe, in a sense, is a perfectly consistent archivist. It has kept every photon, every echo, every fragment of its own memory. The light ahead of you isn't vanishing. It's still travelling, still expanding, still writing itself into infinity. You remember how scientists once tried to see beyond this light, to glimpse what lies before the Big Bang. But that's impossible. The cosmic microwave background is the universe's curtain, the surface beyond which light cannot pass. The early universe was opaque, filled with energy so intense that photons couldn't move without scattering. Anything before that moment is locked away, not because it's forbidden, but because there's no messenger to bring the story forward. Historians still argue whether quantum fluctuations in that primordial epoch left traces that we could one day detect through gravitational waves. For now, it remains the most ancient mystery, not just what happened, but how anything began at all. You take a moment to let the thought settle. The light washing over you has seen everything. Galaxies born and dying, stars bursting, planets spinning, and still it continues outward, carrying no message but existence itself. You stretch out your hand as if you could catch a single photon and imagine what it remembers. You'd be holding a relic from the dawn of time, older than any element, older than light's own purpose. It's funny to think how fragile that discovery was. When Penzias and Wilson made their observation, they didn't know they'd found the universe's oldest glow. Meanwhile, just down the road, a team at Princeton was building equipment to look for exactly that signal. Had communication been a few weeks slower, credit might have belonged to someone else. Science, like space, runs on timing as much as truth. You look around, realizing that this faint, omnipresent light surrounds everything that ever will exist. Even the deepest voids between galaxies still hum with it. In fact, if you turned on an old television and tuned to static, about 1% of that fuzzy snow is this very radiation. Every time humanity stared at that static, unknowingly, they were seeing the Big Bang's afterglow flickering across their living rooms. The cosmos hides in plain sight. A small chuckle escapes you. It's absurd and beautiful. Billions of years condensed into background noise, the first light of creation mistaken for bad reception. You turn slowly, taking in the whole of the horizon. It glows faintly red and gold in your imagination, a perfect sphere surrounding you on all sides. You are literally at the center of your observable universe, because everyone is. No matter where you stand, the horizon stretches the same distance away. It's not a special privilege, it's geometry. The universe expands everywhere at once, making every observer the center of what they can see, and you think that's the most democratic truth ever discovered. The horizon shimmers faintly, like a mirage. It isn't the end of space, it's the limit of information. Beyond it, the universe continues, unknowable, unreachable, still forming, still expanding, faster than light can ever catch. You realize you're standing on the edge not of space but of knowledge. This is the line between what is and what can be known. You take one last look at the faint radiation that began it all, the soft glow that cradles every galaxy and every dream, and you whisper softly, "I see you." The universe, vast and silent, hums back in microwaves. You hover just beyond the faint golden shell of the cosmic microwave background, where light itself begins to lose its right to exist as messenger. What lies ahead can't be seen or measured directly, not because it isn't real, but because it moves faster than knowledge can follow. You've reached the threshold where this expansion of space outpaces the speed of light, where even the universe's own stories are forever trapped beyond reach. You're standing before the wall of light, the cosmic horizon, and beyond it lies what physicists call the unobservable universe. The term feels almost tragic, like a love letter addressed to infinity and lost in the mail. Here, the very concept of distance stops behaving. Beyond this point, galaxies recede so quickly that their light will never, ever reach you. It's not that they're moving through space faster than light, it's that space itself is stretching, carrying them away on an expanding tide. Einstein's equations allow it, nature indulges it. You realize that you're no longer just traveling outward, you're watching reality itself slip away, like a song fading into static. If you could look back toward Earth now, you'd see a tiny sphere of visibility roughly 46 billion light-years in radius, your personal universe. Everything beyond that sphere is hidden not by darkness but by time. Light from those distant galaxies hasn't had a long enough runway to arrive, and thanks to cosmic expansion, it never will. The irony is beautiful and cruel at once. The universe may be infinite, yet each of us lives inside a shrinking bubble of comprehension. You turn your gaze outward again, and for the first time there is no horizon line, just the concept of elsewhere. The mind can imagine what physics cannot touch. You think of the earliest moments after the Big Bang, when inflation expanded space faster than any particle could keep up. The process still continues, quietly, everywhere. The same mechanism that birthed the universe keeps pushing it apart. Historians still argue whether this accelerated expansion is driven by Einstein's cosmological constant, by a mysterious field called dark energy, or by something so alien that human language hasn't yet invented a word for it. Dark energy is the most mysterious player in the cosmic orchestra. It makes up nearly 70% of the universe. yet we know almost nothing about it. It doesn't clump like matter. It doesn't glow or pull. It pushes. It acts as a kind of negative gravity, driving galaxies apart faster and faster. You picture it as an invisible tide flowing through space-time, stretching everything between galaxies, lengthening silence itself. If dark energy keeps accelerating toward dawn, the universe may someday reach a point where even atoms can't hold together, a distant era some call the Big Rip. Historians still argue whether that's poetic hyperbole or a genuine prediction. You hope it's poetic. The name alone sounds like cosmic slang. For now, though, the cosmos is still young enough to be recognizable. Galaxies still form, stars still shine, life still wonders. But as billions of years pass, the horizon will draw closer. More galaxies will fade beyond it, their light red shifted into oblivion. The Milky Way and Andromeda will merge, forming a single elliptical glow surrounded by dark emptiness. Future astronomers, if any exist, will see only that lonely galaxy and nothing beyond. They'll think theirs is the entire universe, just as humanity once thought Earth was the center of creation. You smile at the symmetry. History doesn't repeat in time, it repeats in understanding. You drift closer to the edge, though the word closer is losing meaning. You can't approach what expands faster than you can reach. Still, you feel the stretch the way time itself seems to lengthen. Every second feels infinite. The microwave background fades behind you. The dark ahead grows denser but oddly radiant, a kind of luminous black. You wonder if this is what eternity feels like. Not an endless expanse, but a perpetual unfolding. The mathematicians back home describe it elegantly, the metric expansion of space. Galaxies aren't flying away through space. They're riding the expansion of the space between them. Imagine dots on a balloon. As the balloon inflates, every dot moves away from every other dot, though none are actually travelling. You think of that analogy, smile softly, then remember that it means you're standing on a balloon without an outside. The universe doesn't expand into anything. It expands into itself. There's no edge to fall from, only more existence unfolding where there was none before. A faint flicker catches your attention, a kind of red haze spreading across the void. It's not light in the usual sense, but the stretched remnants of ancient photons, pulled into wavelengths longer than radio waves. Scientists call this the cosmic infrared background, the residue of galaxies so distant that their light has been redshifted beyond vision. Each photon is a message sent billions of years ago, still arriving but so weakened that only the most sensitive instruments can hear it. You realize that you're surrounded by history's last whispers. You try to imagine what lies beyond the horizon. More galaxies, entirely new physical laws, maybe even other pocket universes, each with its own constants and rules. The multiverse theory suggests that inflation never truly ended. It just slowed down in our region, spawning countless other bubbles elsewhere. Historians still argue whether that's science or speculation, but you like the idea. It feels fitting that creation might not have settled for one version of itself. Perhaps every possibility exists somewhere, eternally unfolding, eternally unreachable. You glance backward again and notice something peculiar. The horizon glows faintly, a ring of stretched starlight marking the ultimate boundary of perception. It looks almost alive, pulsing with slow rhythm. You realize that even as you drift and the horizon recedes at the same speed, it's not a place but a limit, always running just ahead. You'll never catch it, but that's fine. It means there's always something left to chase. A small, mischievous thought crosses your mind. If every point in space has its own horizon, and each horizon hides an infinite universe beyond, then infinity itself must be fractal. Every unreachable beyond hides more beyonds, each equally unreachable. It's like standing between mirrors that refuse to reflect the same thing twice. The thought makes you laugh softly, the sound swallowed by expanding silence. You let your gaze fall once more on the black ahead. It isn't terrifying anymore. It feels like potential, like the universe waiting to remember something. Space may be expanding faster than light, but thought travels faster still, or perhaps it simply ignores such limits. You realize, with quiet amusement, that consciousness is its own kind of inflation, always reaching, always trying to see what can't be seen. So you stay there a while on the threshold of the unobservable, feeling the pull of curiosity stretch you thin across time. The horizon glows faintly, a whispering promise from beyond measurement. You know you'll never cross it, but you're grateful for the chase. After all, the universe was never meant to be caught, only followed. The horizon behind you fades until it's no longer a shell of light but simply a memory of brightness. Something the mind insists must still be there even when sight fails. Ahead stretches a silence deeper than sound, a calm that feels less like absence and more like waiting. Here, where the fabric of space expands faster than any light can cross, you finally face the question that has followed you since Earth. Does space even end? It's an absurdly human question, shaped by a world that has borders, oceans, fences, and finish lines. You've been conditioned to expect an edge somewhere, to find a final line beyond which there is nothing. Yet the universe resists such neatness. It doesn't stop, it just keeps happening, like a thought that refuses to resolve. You realize that what you've been calling space might not be a place at all. It's an event, continuous and unfolding, with no outside to contain it. The philosophers were asking this long before telescopes could confirm their suspicions. In ancient Greece, Archytas, a student of Pythagoras, argued that the universe must be infinite, because if you could reach its edge and stretch out your hand would either meet something or nothing, and in either case, space must extend farther. Historians still argue whether he was pondering geometry or having an existential crisis. Centuries later, Giordano Bruno took that same logic and declared that the cosmos held infinite suns and infinite worlds. The church called that blasphemy and burned him for it in 1600, proving that infinity has always made people nervous. You glance outward again, and the scale of the darkness makes the word infinity feel small. It's not just endless, it's alive with potential. The black between galaxies may look empty, but it holds the possibility of everything that could ever exist. You remember something a physicist once said, "The universe isn't infinite, it's unbounded. Like the surface of a sphere, it has no edges even though it's finite. You could travel forever and never fall off. Eventually, you'd loop around and return to where you started. The mind resists this, but your heart understands it instantly. A circle doesn't need an edge to be complete. The cosmic expansion continues around you. Galaxies once faintly visible at the horizon have now vanished, stretched into invisibility by the universe's relentless growth. The blackness ahead isn't new, it's simply unrevealed. You think of the night sky on Earth. How even then, what looks like darkness is filled with unseen light. The photons just haven't reached you yet. Perhaps the end of space is the same. Not nothing, but not yet. You wonder what it means for time, this endlessness. If space never stops, then neither does time, because both are part of the same fabric. Einstein taught that you can't separate one from the other. They warp and flow together, bending around gravity, around matter, around meaning. The past isn't gone, it's just elsewhere, folded behind you like a layer of light you can't quite peel back. Maybe the future is the same, already written, just waiting for the universe to expand enough for you to see it. A strange peace settles over you. For all your questions about endings, the universe keeps offering only continuations. Even death, on cosmic scales, is just transformation. Stars die, but their ashes build planets and people. Black holes evaporate slowly over unimaginable eons, returning their mass to radiation. Every ending folds neatly into another beginning. You realize that space might not stop because it doesn't need to. Stopping implies limits, and limits are a human invention. You think of how philosophers once argued that infinity was impossible because the mind couldn't grasp it. But perhaps that's the point. Maybe infinity isn't something to understand, it's something to participate in. You are, after all, made of atoms that were once part of other stars, atoms that will one day return to dust, to gas, to new stars again. You're not standing in an infinity, you're made of it. Somewhere far behind you in a galaxy you can no longer see, people are still building telescopes, still pointing their mirrors at the dark, and each new discovery expands their understanding but never their satisfaction. The more they learn, the more questions appear, multiplying faster than answers. Historians still argue whether this insatiable curiosity is our species' greatest strength or its most exquisite torment. You decide it's both. the engine that propels humanity forward and the reason we'll never find rest. You turn slowly in the dark, imagining all directions at once. You can't tell up from down, before from after. The laws of motion still hold, but meaning dissolves. You realise that beyond a certain scale, where and when stop being useful words. The universe doesn't exist in space-time. It is space-time. Everything else, galaxies, atoms, memories, is just temporary decoration. And yet, despite that grandeur, your thoughts keep circling back to smallness, to the warmth of air on skin, to the smell of paints, to the human need for boundaries. Perhaps we ask where space stops because we crave a place to land, a point of stillness. But space doesn't end, and maybe that's its gift. If it ended, wonder would too. A faint pulse ripples across the void. Cosmic background radiation red-shifted beyond recognition, the universe's heartbeat slowing as it expands. You listen, or imagine you do. The sound, if sound could exist here, wee-wee, would be almost like you're breathing. Out, 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 forever. You feel yourself breathing with it, matching its rhythm, your chest rising in time with galaxies receding. For the first time, you stop trying to find the edge. You let infinity unfold without chasing it. The question, does space end, fades into something softer. Does it need to? The universe doesn't seem to think so. It simply continues unhurried, serene, certain in its own existence. You close your eyes, not to shut it out, but to become part of it. And in that darkness behind your eyelids, something remarkable happens. You realize it looks exactly the same as the cosmos around you. Endless, silent, complete. You open your eyes, or maybe it's the universe that opens them for you, and the darkness folds into light again, a slow curling of perspective that feels less like motion and more like discovery. You've been drifting in the question of infinity so long that your sense of direction has softened into something circular. And maybe that's fitting, because one idea has begun to bloom quietly at the edge of reason. What if space doesn't just go on forever? What if it loops? It's a strange notion, ancient and modern all at once. Philosophers, physicists, and dreamers have all toyed with it, as if unable to resist the elegance of a self-returning cosmos. The theory goes like this. If the universe is finite but unbounded, then travelling far enough in one direction would eventually bring you back to your starting point. You wouldn't crash into a wall or fall off an edge. You'd reappear behind yourself, like a traveller walking endlessly around a spherical Earth. Historians still argue whether the idea originated with the early Greeks, with Einstein's general relativity, or with some monk staring too long at the night sky. Whoever thought of it first, it remains one of physics' most haunting possibilities. You picture it now, space-time curves so subtly that you could fly straight forever, and one day pass by the ghost of your own departure. Light would do the same, wrapping around the cosmos like a ribbon. In such a universe, the stars you see might actually be duplicate images of the same galaxies, their light arriving from different paths through curved space. Some cosmologists call this a closed universe, a kind of cosmic Mobius strip, finite in volume, infinite in experience. It's oddly comforting, this thought of looping. It makes the universe feel less like an expanse and more like a song, repeating themes, variations, refrains that come back slightly changed. Maybe time itself follows that rhythm, not a straight arrow but a circle. Perhaps the Big Bang wasn't the beginning but just the latest crescendo, one of countless beats in an endless cycle of expansion and collapse. That idea, known as the Big Bounce, suggests that when the universe expands too far, gravity eventually pulls it inward again, birthing a new cosmos from the ashes of the old. You can almost hear the rhythm of it. Inhale, exhale, eternity breathing itself alive. You drift through that thought, feeling both small and infinite. It's funny. Humans invented the word loop for something trivial like string or rope, yet the universe might embody it as its grandest principle. Einstein's equations even allow it. Under certain conditions, the curvature of space-time can fold paths back on themselves. In a universe like that, the word beyond becomes meaningless. There's no beyond, only around. You remember that in 2008, astronomers analysed data from the DOME-MAP satellite, looking for patterns in the cosmic microwave background that might reveal such curvature. They searched for repeating circles, matching fingerprints in opposite directions of the sky. If found, it would mean light had wrapped all the way around the cosmos and met itself. No clear evidence emerged, but the possibility never faded. Historians still argue whether the failure to find those patterns disproved the theory or simply showed the loop is too vast to measure. Either way, the idea persists, stubborn but as gravity. A faint image forms in your mind, an impossible vision. You, floating through the same starfields you passed eons ago, though now they appear subtly altered. Galaxies older, light redder, history rewritten by expansion. You could pass by Earth long after it's gone, circling through its coordinates in space, but not its moment in time. In a curved universe, paths may return, but moments never do. The thought sends a quiet ache through you. Eternity, it seems, remembers geography but not people. Still you smile. There's beauty in that kind of symmetry. You picture a photon of light leaving a distant star, racing through curved space for billions of years, only to arrive back at its origin, carrying the news of its own departure. That single journey could repeat forever, an unbroken conversation between beginning and end. You can't decide if that's tragic or perfect. Maybe it's both. You glance around at the invisible geometry. There's no visual sign of the curvature. Space feels flat, patient, infinite, but then so does Earth from the ground. Only distance reveals the truth. You imagine yourself as an explorer sailing across the cosmic ocean, trusting math as your compass. Somewhere perhaps the path is already curving beneath you, though you'll never live long enough to complete the circle. Still, it's enough to know it might exist. A wry thought crosses your mind. If the universe loops, then perhaps you're already travelling through a place you've seen before. Maybe every wonder you've witnessed, the blue glow of Earth's rim, the auroras in the magnetosphere, the swirling arms of the Milky Way, is destined to repeat. Maybe this very thought, this quiet drifting in the dark, will happen again, in another cycle, under another set of stars. You imagine your future self or past self, whispering the same words, asking the same question, marvelling at the same endlessness. Infinity might be less about distance and more about déjà vu. You think of time the way you once thought of breath. Each expansion, each collapse, each spark of consciousness could be one inhale and one exhale of the cosmos. Maybe death isn't an ending, but a pause between breaths, and rebirth just at the next inhale. That doesn't make the universe gentler, it just makes it cyclical, which feels strangely merciful. Nothing is ever truly lost, it's just waiting to be found again. Historians and physicists still argue whether the cosmos will keep expanding forever, or fall back inward someday, or oscillate eternally between the two. The data suggests expansion will win, that dark energy will continue to push galaxies apart until only darkness remains. But even that ending could be another beginning if time itself wraps around. The math doesn't forbid it, and the imagination practically demands it. You look down, or what passes for down, and see the faintest echo of light spiralling beneath you, a path so wide it seems to encircle everything. It feels like a cosmic smile, as if the universe is pleased that you finally caught its secret. Space doesn't end, it bends. The journey never stops because the destination is always the starting point wearing a different mask. You laugh softly, Estepo, letting the sound disappear into the curve of nothingness. "So that's it," you whisper, not expecting an answer. But the silence around you feels knowing, almost playful. Perhaps it's laughing too, in its own infinite loop of joy. And then, quietly, like a tide reversing, you begin to fall. Not downward exactly, because there is no up or down anymore, but inward, back through the map you've drawn in your mind. The loop of space has curved under you, returning you to the direction of home. The cosmic web fades behind your shoulders, filaments dissolving into faint memory. The horizon of light, the cosmic microwave background, recedes until it becomes a whisper of warmth, the last faint sigh of the universe's childhood. You are not leaving infinity, you are retracing it. At first, the motion feels abstract, a concept more than a journey. But soon the dark begins to thicken, filled again with familiar pinpricks of light, galaxies clustered along their glowing arteries, like cities seen from orbit. The universe that had once seemed unreachable is now blooming back into view, as if drawn toward you by the same gravity that first launched your questions. You pass through the cosmic web once more, threads of invisible matter humming beneath your awareness. The patterns seem gentler this time, like old friends who no longer need to impress you. You glide past the great galaxy clusters, the Coma, the Virgo, the Perseus Pisces, each a spinning metropolis of suns and worlds. Their combined mass bends space-time into valleys you can almost feel. Somewhere within the Virgo cluster lies your own modest home, the Milky Way, a spiral tucked into a quiet neighbourhood of stars. Historians still argue whether the Milky Way is ordinary or extraordinary, but you've seen enough to know that the two are the same thing. Ordinary is miraculous when viewed from a distance. As you move closer, the galaxies resolve into the delicate tendrils of the local group. The Andromeda Galaxy gleams nearby, no longer a distant smudge but a full luminous companion, its spiral arms reaching across the void like open arms. You remember that in a few billion years these two galaxies will merge, but for now they drift peacefully, each circling its own invisible centre. The faint gas between them glows softly, caught in the gravitational tension of their inevitable meeting. You think about how even collisions can be graceful when seen on cosmic timescales. The Milky Way grows larger ahead of you, its spiral arms curling like a living thing. You can see the central bulge glowing gold wrapped in lanes of dark dust that hide countless stars. The galaxy turns slowly, every revolution a gesture written in hundreds of millions of years. You slip back toward the Orion Arm, where the sun makes its quiet orbit around the galactic centre. From this distance, the solar system is smaller than a speck, yet you feel its pull gentle and precise, a thread of belonging tugging you home. You cross into the outer reaches of the heliosphere again, the sun's bubble of influence, glowing faintly against the interstellar dark. The solar wind greets you like a familiar breeze, carrying with it the warmth of a star you once called ordinary, and now understand as divine in its steadiness. The sun's golden light fills your vision once more, not blinding but tender, the way candlelight looks through closed eyelids. It feels like recognition. You pass the orbits of Neptune, of Saturn with its shimmering rings, of Jupiter's swirling storms, of Mars dusted red and patient. You can almost feel the collective hum of the planets, each one a distinct note in the sun's quiet harmony. The Earth appears next, its blues and greens luminous against the black, the thin halo of atmosphere glowing like a promise. From here, the planet looks both impossibly fragile and impossibly persistent. You realise that every sunrise, every ocean wave, every human breath is a continuation of that same cosmic rhythm you felt beyond the galaxies. The moon floats nearby, serene and scarred, still locked in its dance with Earth. You smile at its silver calm and remember the first time you saw it from the ground, how it felt close enough to touch and yet too sacred to reach. Now, after everything you've seen, it still holds the same quiet power. Some things do not diminish with understanding, they deepen. You drift closer to Earth and its textures sharpen, the swirl of clouds, the dark sweep of continents, the glint of rivers like veins of silver light. You can almost sense the breath of life below, the pulse of billions of heartbeats moving in unison with the planet's rotation. Historians still argue when exactly life began here. What spark in the primordial ocean turned chemistry into awareness? But the debate feels small now, almost sweet. The how matters less than the fact that it happened at all. You slip through the atmosphere where the air thickens and hums against your passage. It smells faintly of rain and salt and sunlight, scents you'd forgotten could exist. The blue deepens around you until it becomes sky, until it becomes home. Somewhere below, oceans crash and forests whisper, cities glow and people dream beneath the same stars you've just crossed. You realise that they too are explorers, some through telescopes, some through questions whispered into the dark. You touch the ground, not physically, but in the sense that your awareness settles again among familiar things. The hum of cicadas, the rhythm of waves, the faint crackle of a fire in the distance. Everything you've seen still exists, but it's all here too, condensed into this single planet spinning in sunlight. You finally understand space doesn't stop because it never needed to. The universe isn't something you escape, it's something you inhabit, always and completely. You look up once more through the same thin blue layer that once felt like a ceiling and now feels like a window. The stars wink faintly, patient and knowing. Somewhere out there the questions remain, where space stops, where time begins, where meaning hides. But for now, you're content to let them wait. You exhale, and the sound feels like wind passing through galaxies. The stars blink in answer, as if the cosmos itself is breathing with you. Maybe it always has been.